Good morning, honorable member of Riigikogu, the Parliament of Estonia, distinguished guests, ladies and gentlemen, dear friends. It's my great pleasure to hand over this floor for the opening words to Mrs. Anneli Akkermann, member of Estonian Parliament, and a very marine person. She's coming from a small island, but not in the Gulf of Riga. Anneli, you are very welcome to open this gathering.
Morning. Dear sirs, academicians and scientists, ladies and gentlemen. On this and other sides or shores of Gulf of Finland, I was actually a little bit astonished by the headline of a conference, New Start for the Gulf of Finland Cooperation. I kind of imagine that there has been cooperation between people on all shores of Baltics since first inhabitants settled down. Maybe with disruption for 50 years, from 40s to 90s of last century. Anyway, same waters are washing all the shores of Baltics. Seals and fishes do not know borders between states. Nowadays, sailors with small boats and travelers with big ships nearly do not notice the borders between our countries, if not to consider COVID restrictions. As well, marine pollution and all kinds of problems with ecosystems do not know borders between countries also. All nations around Baltics share the waters. They have to share all the problems and challenges as well. In these days, there are 5 draft laws on the desks of members of Estonian Parliament. 3 of them concern maritime safety legislation. How we can support and subsidy traffic between Estonia, Finland and Sweden so that ships are still cruising and keeping connections between countries. And there are 2 main measures to reduce charges of harbors and seaways, and the other measure is to give back certain amount of labor taxes to the shipping companies to avoid them to redundant jobs at sea. And there is another draft law of maritime safety law to recognize diplomas of sailors, which means actually taking over European Union directives. But there is the 3rd draft law, which is not actually maritime safety law, but unexpectedly building law. And this is most influential draft laws concerning the sea right now in the Parliament. This is construction law due to huge demand of building rights to build wind parks and infrastructure to serve them. But not only, there are also a demand of building rights of the infrastructure of aquaculture as well. And one more draft law, which is maybe interesting to this public here, is mostly concerning handling waste of ships, so that every harbor has to take or organize taking most of the waste that could emerge on board. Also, every ship has to report ahead of the waste on board, and harbors had to report of quantities of wastes taken, which is also actually implementing a EU directive to Estonian legislation targeting to minimize the wastes thrown to the sea by the ships. As everybody has noticed, we are in great demand of energy. Prices of electricity are making new records every day. Green Deal and Fit for 55 are standing just ahead of us in the nearest future. And we should be blind if we do not notice what the pressure it puts to the sea. We want to carry more goods via sea. We want to produce more food in the sea. We want to produce more energy at the sea. Such kind of wishes we see on our desks at the parliament. According to that, I can predict that there are a lot of big problems of this type at your desks also. How can we serve all those expectations? How to share the sea between those big developments? How sea as an ecosystem can survive as we have known it? No doubt, you have serious topics to discuss every day in your working life and during those 3 days here in Estonia. I wish you fruitful discussions, good ideas, and smooth cooperation for years. Thank you.
It is so unusual that somebody among policymakers has such a good understanding of marine matters, but that's clear given the area from where she is coming. So it is really a great pleasure to open this very traditional event now, which is one of the main outcomes of the trilateral cooperation between the countries that surround the Gulf of Finland. And this is not only the easternmost large sub-basin of the Baltic Sea. We know that this water body receives by far the largest river discharge into the entire Baltic Sea, and it also hosts the largest city on its shores. So the result is that the status and health of the Gulf of Finland both serve as very good indicators of processes that affect the entire sea. In our times, it has become already a cliché that the entire world is rapidly changing, and that actually the history is now separated into two parts, before COVID and during COVID. There is not yet after COVID, but it will come someday. But those transitions are actually very wide. And they also involve some transitions on the academic landscape. And those transitions have touched the very foundations of how science functions, and even more, how it serves the society. So in the past, there was a bit more contrast form. There was a strong chain, which was localized both in space and time. And this chain has steered the use of scientific products in the relatively recent past. So this change, a little bit imaginary, but still really working, it connected a scientist working in a laboratory with an inventor in a neighboring room, and then involved an engineer in a neighboring floor, and ended up at a manufacturer running a factory next street. So the scientist was paid from the profit earned by the factory. So this straightforward chain doesn't exist anymore. It has been replaced by two almost completely separated groups of people. On the one hand, many excellent scientists contribute to the global pool of knowledge. On the other hand, inventors, engineers, and entrepreneurs, so to say, fish for ideas in this pool. So the production and use of knowledge is very much disconnected now, both in space and time. So a few successful catches from this pool are not, as also in the past, converted into sort of new cool items. The subsequent production and sales generate now public tax money. So a large part of science is funded from this public tax money today. So both the pattern of knowledge production and the pattern of using of this knowledge have been radically altered. during last few decades. It's absolutely natural that society reacts to these alterations and also ask scientists how do they manage their fields in this new situation. So the classic short definition of science is that science is an enterprise or perhaps even an adventure that has two components or pillars. First, obtaining new and essential information, what we do every day, and second, communication of this information to others. And this is what we do today to our fellow scientists. So, but when I look into this definition, then an example of a new and essential information is a fact. The foundation of science is facts. So fact-checking is among the first things what we teach to young people who decide to be engaged with science. But we normally do not treat all facts equally. For example, it's easy to acknowledge that it is fundamentally impossible to exactly forecast weather or ocean currents for the next year. Moreover, some facts are inconvenient. For example, we all have to pay taxes and we all shall die. And some facts are politically sensitive. For example, the carbon dioxide footprint of Estonia per person is still enormous. And the status of the Baltic Sea is still far from being good. So, the difference between science in the classic interpretation and typical problems or necessary solution for society on the other side is really significant. And this discrepancy has been perhaps best expressed by Michael Deacon in the Daily Telegraph magazine already 5 years ago. He summarized the core message of today's so-called post-truth facts as a very simple trilemma. First, facts are negative. Second, facts are pessimistic. And third, facts are unpatriotic. It seems strange, but still, if you think over those negative, pessimistic and unpatriotic facts are actually a major asset for both science and society. So the pool of such facts which are unpatriotic at the very end, it produces extremely important knowledge. The knowledge that prevents us from taking wrong decisions or over-exploiting natural resources or also damaging of fragile marine and coastal ecosystems. I must say that such pool of facts is an unavoidable part of progress in science. So it is specifically the inconvenient facts that often direct us towards out-of-the-box thinking and to find new ways. And sometimes we need regulative measures to nudge the society. Just remember the old-style light bulbs, which some of them are still here. They produce more heat than light. Now we have light-emitting diodes that are hundreds of times more effective in production of light. The line of thinking that was used before the facts became negative, pessimistic, and unpatriotic, it's sometimes called or framed as the glorious glorious past of science. It actually belonged to the time when both system uncertainties and also stakes were low. This is typical, for example, for Newton's laws. Now, also in our science, we are facing another situation which was partially framed by Mrs. Ackerman. Even though we know radically more about the world compared to Newton's time, our knowledge about nature and even more about science and of course about function of complex systems, still have massive uncertainties. And the stakes are also extremely high. So rapid climate change or the possible damage to marine or ocean ecosystem, say by microplastic, may put large parts of civilization at stake. And still we have to make rational and forward-looking decisions. And this situation is actually framed as the fourfold challenge of so-called post-normal science. First, facts uncertain now. Second, values in dispute. Third, stakes high. And fourth, which policymakers feel there's no time for thinking. Decisions are urgent. They have to be made today or tomorrow at latest. So, it's in a way natural that this kind of principal change has generated also major alterations in how knowledge, also science in general, is used on both local and global levels. In a perhaps over-exaggerated way, the essence of science is looking legitimately into the future. And such a glimpse is only possible based on perfect knowledge of the past and also excellent recognition of the problems to be solved. The core point of the role of science has been formulated, to my understanding, in the very best way by Professor Helmut Schwarz. He's a foreign member of Estonian Academy of Sciences and one of the former colleagues and also in some sense one of the former teachers of Angela Merkel. So he has said in a private conversation, I'm citing, "Without science, we are unlikely to be able to construct a future that is worth of living." So here we specifically contribute to the future that is worth of living on all shores of the Gulf of Finland. Having said that, I have some housekeeping rules to announce. They are really simple here. In an extremely unlikely event of, for example, earthquake or tsunami, the exit from this room is through the wooden doors to this side, and then run straight out of the building. Do not use the glass doors on the other side. You will not survive. Bathrooms and wardrobe are located, as you probably already know, on the lower ground floor. And even though we have a few, I would say, business class seats separated a little bit from others, we are still in the impact field of COVID-19 virus. So please wear mask when not presenting or when not drinking or eating. Of course, you may have filtered coffee through your mask, but it's up to you. So please try to keep distance. Please disinfect your hands regularly. And last but not least, to every speaker, please keep the schedule. Try to fit into the allocated time slot. You know, there is academic freedom in this building, but it doesn't apply to schedule. The freedom is applied when we construct the schedule, and then we follow it. Okay? Agreed. Good. Then, without any break, we shall proceed to plenary session and keynotes. When we were deciding the keynotes, we decided that every side of the Gulf of Finland should have one keynote. So we have one keynote from Finland, one keynote from the easternmost end of the Gulf of Finland, from Russia. And then we decided, since differently from Finland, Estonia is connected to European Union over Suwalki corridor, not by bridges, then Estonia was considered in a wide sense as the rest of European Union, and we have chosen the third speaker from, so to say, the mainland of European Union. So it is my pleasure to announce the first plenary speaker, who is Heikki Pitkänen from Finnish Environment Institute. And the title is so long that I think you better read it on the screen out my interpretation. Heikki, you will have 20 minutes plus 2.5 minutes for questions. Is that okay? Agreed, thank you. You're absolutely welcome.
Mr. Chairman, dear colleagues, ladies and gentlemen. First of all, we presentation of this talk together with Seppo, Knuutila, Jouni Lehtoranta and Mika Raateoja, who is now in Helsinki, probably watching this. We are very thankful for having this opportunity to have this keynote talk. We appreciate this very much. Our topic is comprehensive monitoring of nutrient concentrations and loads and its importance from judging the changes in the state of the Gulf of Finland. And in these evaluations. This topic is by no means a new one. Before coming here, I look at my archives and found that we have had similar topics in the scientific meetings concerning the Gulf of Finland and the Baltic Sea already in the 1980s. And for example, my first presentation has been in 1986 in the joint Gulf of Finland meeting here in Tallinn. So, going to the presentation. Do I have to next? Okay, this is shortly the contents. First, something about the main processes affecting the trophic status of the Gulf of Finland. So, what is the role of internal processes? How do they affect the trophic status and nutrient dynamics? And on the other hand, what's the role of the land-based loading? Then we will have some examples on long-term nutrient trends, not very many, but some, let's say, examples using representative data from the middle and eastern Gulf of Finland. And also looking at the long-term variations. For example, the question is eutrophication of the Gulf of Finland still continuing? Then one really important question is the quality assurance. During the Gulf of Finland year, we noticed that even the data of nutrients, it's not fully comparable between the different countries. And finally, we have some proposal for the future Gulf of Finland trilateral cooperation. So first about the role of internal processes, nutrient transport between the basins, and especially the role
Recording stopped.
Okay, thank you. The role of the Baltic proper, which has proved to be really important, also controlling and regulating the state of the Gulf of Finland. Here is, okay, I can show here. This is there is a schematic presentation from the paper of Lehtoranta and the others, how during eastern, northeastern, and also weak westerly winds, the role of the large nutrient storage in the Baltic proper can be and is really important, also controlling the status of the Gulf of Finland. And also, it's really important to notice that when external nutrient load from the drainage basin of the Gulf of Finland has strongly decreased in recent decades. On the other hand, the role of the Baltic proper and the anoxic water volume has increased very strongly, and its role has become more and more important all the time. So even the present annual load of land-based phosphorus is somewhere between 3,000 and 4,000 tons. It's as such it's a big amount. It's important to notice that it's only 10% of the wintertime total phosphorus content of the Gulf of Finland. So it's possible when further decreasing this load, it's self-evident that decreasing the load affects the state of the Gulf very, very slowly. Here are some examples about very strong nutrient load reductions from the main point sources around the Gulf of Finland. So these are cities. Of course, the most important is the load from St. Petersburg, which has decreased really strongly from the 1980s. Both phosphorus, this light gray, and also nitrogen. Light gray is nitrogen and dark gray is phosphorus. But similar, in a smaller scale, similar development also in the Helsinki-Espoo region and in Tallinn. Then we had this a bit surprising episode via the river Luga, where we had very high phosphorus inputs from this phosphorus gypsum stack in the town of Kingisepp, which affected the loads of river Luga, and in a way, for some years, counteracted the decreasing load from the other sources. Then some examples about the trends. We have here from the LL7 station, which is between Helsinki and Tallinn. We made handled some extra data after the Gulf of Finland year. So these orange dots are after 2015, and notice that there are certain changes. The long-term trend regarding both phosphate and nitrates, the long-term trend is increasing, but for example, regarding phosphate, there is a change that we had a slight decreasing trend in the 2000s before 2016, but then the situation changed because we had these major Baltic inflows in 2014, between 2014 and 2016, which again increased the concentrations here. Regarding nitrate, the trend is not as clear as for phosphate. Very strong increase in the 1970s, 1980s, along with the general eutrophication development in the Baltic Sea. But then, if you look at the salinity trend, there is an average decrease from the 1970s, which means that the role of river water has increased all the time. And it affects especially these certain higher concentrations. The general trend is there is no trend in the 2000s, but in a way the variation has increased. And talking about the reliability of the data, we really checked the Finnish data. We noticed that the Finnish data between 2000 and 2014 is not okay, and made a study and noticed that concentrations below 0.7 micromoles or 22 micrograms per liter, they are not, or the uncertainty had increased, and we decided to delete these values, let's say from normal use. You can't get them anymore automatically from our database. You can get them if you want, but then you had to make a special handling for the when you are picking up the data. These are figures from the Eastern Gulf, from Finland. This is the station south from Haapasaari. It more or less presents the open sea conditions, and here you can see the same effect. So this is now total phosphorus, summertime total phosphorus. This downward trend, which was noticed during the Gulf of Finland year 2014, ends here, and the New Year data is clearly higher, and our analysis is that, or we think that the main reason for this is these Baltic major inflows, or they are indirect effect, which pushed this old deep water into the Gulf of Finland. And also we can see here that near bottom salinities, especially in 2018, 2019, they are clearly higher than the average level. Now, here are something about the challenges which make the judgments related to this basic monitoring data a bit challenging. So there is the basic thing is the estuarine-like. Oh, I had to show from here. Yeah, estuarine-like system. So we had a strong freshwater effect in the east, and then saline, nutrient-rich water input below the hallock line from the west, and these different water masses are mixing and causing strong gradients. Monitoring aims to follow and analyze changes caused by anthropogenic loading to help to perform measures to reduce this loading and improve the state of the ecosystem. And these anthropogenic effects, of course, should be possible to separate from these, let's say, natural effects. Of course, these natural effects also nowadays contains anthropogenic nutrients as well. But this is very challenging because, especially in the open sea, the amounts of loading are much more than those caused by processes in the sea. So theoretically, if we, for example, cut 1,000 tons of phosphorus from the inputs from the drainage basin, on average, it means only 1 microgram or 0.03 micromole of phosphorus in the let's say compared with the whole water volume of the Gulf of Finland. So it's easy to understand that seeing the effects on the state of the Gulf takes really a long time. Then some words about the importance of quality assurance. I already mentioned the problem we had in Finland. During the Gulf of Finland year, this kind of comparison between Estonian and Finnish concentrations from the stations near to each other were made, and theoretically, of course, they were not made from just the same samples, but this value should be quite near this 1:1 level. But as you can see, the deviation is quite big. Of course, the different sampling times, for example, explain part of this. Then Mika Raateoja arranged an intercalibration experiment in 2019, and those results were quite good. So the differences were mostly acceptable. Then I also mentioned the problem with the river monitoring. So this is from Neva. We have here flow and here phosphorus flow, and practically no correlation between these two others. There should be, because flow, this export is also including flow. So there should be a positive trend between these two. And finally, some proposals regarding the future Gulf of Finland cooperation. The present situation is that monitoring based on research vessels still forms the basis for this monitoring. It's important to have good coordination between the three countries, and really this nutrient data very much forms the basis, and especially the winter data forms the basis for analysis about the trends and explains the changes in eutrophication. Of course, measurements should be developed, and there is going on development with the moored automatic stations, ferry box work, etc. And from these measurements we will get the needed high-frequency temporal coverage data. Regular intercalibrations are needed between the countries, as was done in 2019. So it should be a continuous process. And we also feel that data exchange and annual reporting, as was done in connection with the Gulf of Finland 2000 year, should be a regular biennial process to follow the data quality and changes in the state of the Gulf of Finland. This applies both monitoring nutrients in both seawater and land-based sources. Thank you very much.
Thank you very much, Heikki, for making clear that it takes time for the sea to become cleaner, and that there is enormous uncertainties in what we are doing. Any questions, please? Yes, Kai. Please use the microphone so everybody will hear.
Thank you. Thank you, Heikki, very much. I think that this message which you taught about the role of internal loading and this major Baltic inflows in comparison with the reduction of the external loading is sometimes not reached by our society, because often you hear just that we should decrease the external loading, but now you show that it's not maybe the very quick solution. So what do you think that we should do to give to the stakeholders and decision makers a more updated view of the situation? Thanks.
Yeah, I believe that, or also my colleagues agree that we should still reduce the external loading as much as possible, because slowly it will affect. But in shorter time scales, it's this nutrient exchange with the Baltic proper and internal processes which really affect. We have good signs in the eastern Gulf of Finland. There are clear trends in the Russian side of the Gulf of Finland, where the main load decreases have taken place. There we have decreasing trends which are mostly caused by this decreased loading. And it affects also elsewhere, but it's masked by these processes.
Yes, a theoretician may say that let's dry the Baltic Sea, clean bottom sediments, and put new water in. Okay. You don't agree? Me too. Thank you very much, Heikki.
Thank you.
And we now switch. Yes, of course. Big hand. And we now know that the sea is not only water. It is there is an interface between where people are living and where fish is living, and it's called the coastal area. And Darja Repchuk will tell us about Gulf of Finland coastal systems. Welcome. You may freely move here. Yes, thank you. You will be heard, but keep yourself somewhere here mostly.
So, first of all, I would like to thank our hosts and organizers, as really some miracle, it seems to me. To be in real conference, it's so rare chance for all of us. During the last 2 years of COVID disaster, we understood very clearly that how important is not just cooperation, communication. How important is to have opportunity to shake hands and have a cup of coffee. So thanks a lot. And the other thing that I would like to say, being here in something goes wrong. Yeah, being here in Estonia and talking about coastal systems, I can't not to say some warm words about Karel Orviku, the great Estonian coastal geologist. When I was a student, his book Coasts of Estonia was standing in my bookshelf, and I suppose that he's one of the famous ancient geologists. But when we met, I was found that he's so active, so young, so open and friendly. And at that time we started to study our Eastern Gulf of Finland coast, and he just invited me to Tallinn and gifted me enormous collection of his data, which he harvested in late 80s, writing the book about the Gulf of Finland geology. So we will remember and miss Carl. And as all of you know, maybe, I represent Department of Marine and Environmental Geology of Russian Research Geological Institute, and the main focus of our study is marine geology and coastal geology of the Russian Baltic, including Gulf of Finland. But it so happened that recently the geographical area of our investigation has shared a lot, up to the most northern and eastern, absolutely unknown and unstudied areas of the Russia. And actually it's very challenging and very interesting, as every time you study a new area, you have to study the new piece of geology. But also it's a bit easy, as you can be sure that every new long core or every new geophysical profile produce absolute unknown and new information. But what is important? The more interesting places we visit, the more we like our Gulf of Finland, as we understood very well that it's so scientifically interesting and so important for human being part of the world ocean. So we still have a lot of unsolved problems, for example, concerning deglaciation. Why it's important for the coastal processes I'm trying to demonstrate today. Also, there is still a big discussion about the amplitude, time, and even number of Holocene regressions and transgressions, and how it is important for understanding of coastal development, even for prediction of the future. It's obvious. Also, the problem of coastal erosion, which is, of course, maybe most important for our easternmost part of the Gulf. It's very important from the practical point of view. For example, this map of Kotlin Island, its western part, demonstrated somewhere the annual rates of coastal erosion is more than 2 meters per year. So just to remind you that coastal zone is the space of interaction of lithosphere, hydrosphere, atmosphere, and biosphere. And this is the 3D image of the coastal zone. But when we are taking into account the time, we have paleogeographical reconstructions of coastal zone development and prediction of the future. You know that approximately 50% of world population lives within the very narrow ribbon of 100 meters from the shoreline, and a lot of big cities are located here, and our Gulf of Finland is the best example of. We know the coastal zone, both its onshore and offshore parts, from environmental point of view. And our coasts, they are just beautiful, so we should be very careful when in every our human impact on the coast. For the impact, this is an example. Here are the natural coasts of the Neva Bay. By the way, it's a natural reserve, but they're not so, not so beautiful, not so attractive. And this is one example of the human impact. And I can say, I hope that everybody will agree with me, it's the good practice. And this is the other example. It's waste disposal on the easternmost part of the Gulf, of the Neva Bay. Fortunately, I can say that now it's a bit better. But there are still some hot spots which are important sources of pollution. And now to the main geological factors affected the coastal zone development. First of all, for us, it's glacial isostatic uplift. And again, Gulf of Finland demonstrates the perfect scientific example of the very high gradient of this tectonic movement. In St. Petersburg now it's about, you can say, 0, while in the southwest of the Gulf, in the Finland, it's very high. Then coastal pre-quaternary geology. The metamorphic and magmatic rocks of the Finnish coast demonstrate this scarce type of the coast, and the cliffs of Estonian cliffs are caused with development of sedimentary rocks. And as for the easternmost part of the Gulf of Finland, all these pre-quaternary rocks are covered with easily erodible quaternary deposits, which caused very high erosion rates. The other important feature is very smooth and rather shallow bottom and coastal relief, and it leads to development of the relict coastal forms both above and below recent sea level. Then, when a very important factor of the coastal development was glacial erosion, which lead to this wide and narrow and big base of the southern coast. Then opposite processes of glacial and fluvioglacial accumulation, the melting ice retreating to the north, leave a lot of material, sand, gravel and boulders, again both offshore and onshore, which during Holocene became the main source of the coastal zone development, coastal zone form development. And this is our favorite area of investigation for Estonian and Russian geologists and archaeologists, Narva-Luga-Klint Bay, which is very well known due to brilliant publication of Alar Rosenthal. So why it's a very interesting area? Because here, during Holocene was formed a lot of different size and origin and shape, a lot of accretion forms. And here, the lagoon system, like recent Curonian lagoon and Curonian spit, or Vistula lagoon, Vistula spit, was existed. And this environment was very favorable for our Neolithic and for Neolithic people. But actually, one of the interesting questions was to construct this huge accretion form. What was the source of material? And we pay attention on some strange, after analysis of the coastal relief, we pay attention of some strange accretion form, which is actually perpendicular to the recent shoreline. And after the ground penetration radar study, we have found below the dunes and marine sediments, this on this picture, it's green, dark green color, a very specific bedding, a very steep bedding, and it was interbedding of sands and gravels, even small boulders. So this is the typical structure for the river delta, but it was not possible to even hypothesize such a river, which should go from the Gulf up slow. So what is it? It's actually glacial fluvial delta, and this conception is very well correspond to paleo reconstruction of our Estonian colleagues. So the huge amount of melting material, ice material melted from melting ice sheet was deposited here. And after that, during Holocene, it was the source of construction of the different generation coastal forms. And here is also a perfect example of interdisciplinary research. I already said that this area was for a long time known as the place inhabited of Neolithic and early metal people. But after the careful analysis of relief, for example, we found that here should be two twin spits. And in this spit, there was some sites very well known. And we sent our colleagues, archaeologists, to the other one, and they really found the archaeological site of the same age. So this is an example of the coastal systems development during Holocene. And I have no time, just very shortly mention that this same system, but a bit smaller size, we have also around Sestroretsk, again lagoon, a sand barrier, and again very favorable environment for people. And again, ground-penetrating radar demonstrate us that the source of this material was glacial fluvial deposits. And the third example, which is located exactly in the center of St. Petersburg next time, when you will come to St. Petersburg, for example, from Moscow by train, and you will cross Nevsky Prospect, just look to the left, and remember that you are standing on the former sand barrier, so-called Ligovskaya Spit, and to the west of you there is former litter in the sea bottom, and to the east of you there is former lagoon. And again, the fantastic Neolithic site, so-called Ohta Cape, was found here during the archaeological investigation in the when it was the plan to construct the skyscraper in that place, and near Ohta River. And first archaeologists has found Swedish fortress, then medieval Russian village, and below this fantastic Neolithic site with more than 12,000 items. So this was about the Holocene transgressions, but the other interesting question, which is still unsolved now, is the level of regression. As the level of transgression we can calculate, we can find, studying both archaeological evidences and lakes, which during the sea level rise became the part of the sea. But what about regressions? When we started a careful study of our sea bottom, we have found that practically all coasts of the eastern Gulf of Finland are surrounded by sand terraces. To date these terraces is a very big problem, and practically it's not possible to decide it right now, because you need some boring and dating, and it's a very expensive process. But all modeling has shown us, geological modeling, that the only chance to construct such a terraces should be rather deep drop of the sea level. And for a long time we had no any direct evidences of such regressions, but very recently, again, our Estonian colleagues produce fantastic, very interesting investigations over Pärnu Bay. Pärnu Bay is not Gulf of Finland, but it is located exactly in the same isobars of glacial isostatic rebound. So they have found the delta, and now we can be proved that this, at least pre-Lithuanian regression, was really deeper than it was supposed before. But the questions, there are still some questions. For example, we have a very interesting area of the southern part of the Gulf of Finland with a long-term existence of sand spits. And we have evidences that some kind of lagoon existed here about 2.5 kilo age ago, and that that time the sea level should be lower than nowadays. And again, geological model support this hypothesis, but unfortunately the data from Estonian coasts are quite contradictory, as you can see on these graphs. So this is the question of the further investigation. And this is the main conclusions about the past. Glacial and glacial fluvial deposits are the main source of material for coastal zone development during Holocene. That during maximum stage of littorine transgression, there were several open bays connected with littorine sea, and that the typical feature of the Gulf of Finland was lagoon systems, which were very good place for life of the Neolithic and early Metal Epoch people. And also that there were rather deep regressions during the Holocene. Why it's so important for the recent coastal zone development? Here is a GPR ground penetrating radon profile, sorry for Russian, but as you can see, this is the place where onshore we have a huge amount of sands. And let's look on the same place now near shore. You can see that the main feature of the coastal zone here is deficit of the sand material. So why? Because of glacial isostatic rebound. Yeah. So around the eastern Gulf of Finland, we have a huge amount of sand material, but it's not available for the waves anymore. This deficiency of sand material is one of the very important reasons of intense coastal erosion for the area. It's very good to study Gulf of Finland coast, as we have a lot of archive material. Please pay attention. The young lady is sitting on this monument, and you can see the level of the sand and how wide was the beach that time. And in 100 years, another young lady, which now present in this audience, is standing. So here we have more than 2 meters high and about 30 meters wide beach, which has been eroded. And of course, it causes big damage to the infrastructure. And this profile, again, it's one of the profiles presented to me by Karel Orviku. It was the situation, and here the pictures of 2087, 2088. It was the only sample of good coast protection practice in Eastern Gulf of Finland when the artificial beach was constructed. After that, this equilibrium profile was developed, and then slow coastal erosion up to 2011, when the situation became worse than it was before. And now, very quickly, just some examples how it goes. Year by year, storm by storm. These are results of laser scanning, and it demonstrates the mechanism of the erosion when the worst damage is observed around the escarpment or the dune. A very important role plays coastal morphology, as we have found the nearshore runnels, which are the waves of the sediment loss. And this slide demonstrates the red area in the down panel means the areas of bottom erosion. And when we just have a look at numerically stimulated mean values of significant wave height, which is in Eastern Gulf of Finland is about 25 centimeters, this kind of processes seem to be just impossible. But let's pay attention on the maximum values. And it was so long ago, when it was 10 years ago, actually, when we, together with Professor Solmere, found these 3 main factors affected the extreme erosion events. It should be long-lasting western or southwestern storms, high water level, and absence of stable ice. And let's think that all these factors are climate dependable. And since then, our next observation just supported this hypothesis. As you can see, we had big erosion events during 2013, 2015, and actually this November. As Tarmo had already said, these processes are fundamentally unpredictable, but the mathematical modeling has shown that if the frequency of these extreme events, which now is much higher than it was during the second half of last century, the rate of coastal erosion will accelerate. And again, this slide demonstrates one of the pessimistic and how Tarmo already said, unpatriotic scenarios of coastal development. According to this, we can lose a big amount of sandy beaches. And technogenic processes, very fast. First, of course, St. Petersburg Flood Protection Facility. These slides demonstrate how different is its impact within the Neva Bay. As you can see, it's the same storm, very hot storm of 2013, but there is no wave and the level is rather low within Neva Bay, but the situation is even worse outside of the coast protection facility. And my last slides again, about disconnection between the science and practice. We know very well what we should do and what we shouldn't do. And just pay attention. This is a very stable beach in 2006. Then 2013, a construction of the seawall. Several months later, you can see heavy erosion, and now more and more hard protection and worse and worse situation. So this is the same place. We have no this beach anymore. Another beach. Another piece, you know, what is important? I communicate with the people who, engineers who constructed this. They are not, you know, evil persons from the Hollywood movies. They didn't want to destroy the beach. They would like to organize very good environment for people, for children, but they just didn't ask some important questions to science. And my last slide. Again, a very bad sample of the coastal management, and this is my favorite, you know, diagram of geological time. Let's remember that we are here just about 4 seconds, and let's be very careful when we do something, and let's use the science every time we do something with coastal systems. Thank you very much.
Thank you very much, Darja, for showing how beautiful and amazing are the shores of the Gulf of Finland and how interesting they are from the scientific viewpoint. We have just time for one relatively short question, if there is any. I think that we have had a beautiful experience of a very informative and fantastic talk. So everybody is shocked. Let's give a big hand to Darja once more.
Thank you.
Thanks a lot. And the next presenter will be joining us remotely. He is Markus Maier, who is sharing himself between Sweden and Germany. And I think he will talk, he will focus his modeling results today on the past and future climate change in the Gulf of Finland region. Markus, are you with us?
Yeah, hello. Can you hear me?
Yes, great. And
okay. Thank you, Mr. Chairman.
Welcome.
Yeah. Hello, everybody, ladies and gentlemen. Thank you for the introduction, Mr. Chairman. And I would like to present some current knowledge about past and future climate changes in the Gulf of Finland region. I'm from the Leibniz Institute of Baltic Sea Research, so from the southern Baltic Sea, but I'm also located at the SMHI, the Swedish Meteorological and Hydrological Institute in Sweden. And I'm very thankful for the invitation to the organizers. Thank you. And I hope that you can see now my slides. Good. So, my motivation to go into this current knowledge about past and future climate is that you find in the literature and in the public perception many statements that we may doubt that they are true. For instance, the Baltic Sea salinity will decrease in the future. There will be less saltwater inflows into the Baltic Sea. Storms will be more frequent and extreme sea level events. There will be no decrease in hypoxia. So hypoxia, the depletion in oxygen for the Baltic Sea, we heard already, it's record high today. And it will not decrease due to climate change. And there are more cyanobacteria blooms in the future. So my question is this supported by current knowledge? And I would like to convince you in my talk, no, it's not. So what is it about? Within the science network Baltic Earth, an independent network addressing the Earth system science in the Baltic Sea region, regional climate assessments have been done since decades. So some regional IPCC reports, one can call it, the Baltic Earth assessment reports or Baltics assessment reports on climate change, that was the previous name. There was a book published about the status of our knowledge in 2008, another one, an update 7 years later in 2015. And then presently we are working with the third update of our knowledge. It's called BEAR, the Baltic Earth Assessment of Climate Change for the Baltic Sea Basin. The format has changed, so it's not a book anymore. It will be a special issue in a scientific journal, Earth System Dynamics. And all these activities from the scientists have been in collaboration with HELCOM. And HELCOM in previous years published from the material of the scientific oriented books, own reports. Now it's actually different. We work together with HELCOM to produce a climate change fact sheet, and this has been published in September this year. And you can download it from the HELCOM homepage if you are interested. So there's an ongoing collaboration between stakeholders and scientists, and I think that's very good to inform the public about the current knowledge. The article that I want today focus on is this one. It is under review. Climate change in the Baltic Sea region, a summary. And it's the knowledge gain since 2013, so since the last one. Based upon peer-reviewed papers, there are 33 parameters of the Earth system that has been addressed. Actually, it addresses all the parts, not only the water in the Baltic Sea region, but also the atmosphere, the land, the cryosphere, and so on, but not the anthroposphere. That was a decision by purpose that we said we focus on the physical, chemical, and biological parameters. So it addressed past, present, and future climate changes. Past means paleoclimate development, like presented by Daria before. Present changes means the changes during the instrumental period, and future changes from projections. 47 scientists participated. It's now 205 pages with a lot of figures and tables and more than 800 references. And if you are interested, you can join this process. It is on the internet, and you can see the submitted version already and the comments that we got so far. This is the summary that I will discuss in more detail during this talk. The 33 parameters are shown here. The drivers are, of course, the atmospheric CO2, the red boxes, and the aerosols that affect the radiation budget and the temperature in the region. And then we have the different compartments of the Earth system in light orange or brownish, light brownish color, the atmospheric parameters, in grayish, the cryospheric parameters, in blue, the ocean parameters, in dark green, the biosphere on land, and light green, the biosphere in the sea. And the dark brown is actually land parameters, physical land parameters, and all they are affected. And I will go and explain this overhead more in detail later. I should say, if you talk about current knowledge, it's very important to address confidence levels. And here in this assessment, we followed basically the IPCC philosophy, that we have 3 levels of confidence, low confidence, medium, and high. And this is according to agreement, consensus in the literature. So simply speaking, it's about the number of publications that stress a certain finding, or the evidence, type, amount, quality, consistency. So for instance, if you detect the trend in your data and this is statistically significant, you will increase the confidence if you have also an explanation, for instance, by models, if you can not only detect, but also attribute the change to climate change. And here, again, it's very important to stress there are many different factors influencing the Earth system, but the paper only focused on the climate change. And these are the pluses and minuses. So look, for instance, in the upper part of this transparency, air temperature, you have pluses in black. These are the past changes, and 3 pluses means high confidence. So plus, that is, of course, an increase in air temperature with high confidence. And the projection is the same. The increase is with high confidence. If you have other bubbles here in this diagram without any sign, then it's simply that we do not know. Okay, I will come back to the arrows later. Let's talk about present climate change. Because of the previous talk, I have not focused here on the paleoclimate changes. I skipped that, so I will focus on the instrumental period. These are data from land-based station over the whole Baltic Sea region. It's actually in blue, the curve show the Baltic Sea basin in the north, and then red in the south. And the division has been done at 60° north. And you see the different seasons and the annual mean. And it is very obvious that there is an increase. You see it just by eye without applying any statistical methods in wintertime and in spring. And this increase is larger than the global average. It's slightly larger than estimated in the earlier back reports. So we can say there is an acceleration in the trends. And so it's getting warmer and warmer. So the last back report, to remind you, was more than 7 years ago. So data from 2013. Now we have an increasing warming. And this affects the cryosphere especially. Here you see the sea ice extent, the ice coverage over the whole basin. And this starts by reconstructions already in 1720 and has been continued until today. If you focus on the 2 time slots in the at the beginning of the last century. And the present period, you see there's a shift in the distribution. So there occur no very severe ice winters anymore. That was the case before. So there was a bimodal distribution function for the occurrence of ice winters. Now it's actually more shifted to milder winters. And there's a trend, a significant trend during the past decades. If you look at river discharge, another very important parameter for the salinity in the Baltic Sea, this is actually not the entire Baltic Sea, but the slide shows the data from Sweden, because here the latest updates have been done. But if you look at the curve for the entire basin, it's actually pretty much the same. So you see here no trend. There are wetter decades and drier decades, but there is no significant trend in that. So and also the high flow events, so extremes in this over the past 100 years are not statistically significant. But if we look more into the basin structure, if we look into the north, and this is this slide about, it's from Sweden, and divided into the different parts of Sweden from north to south. And if you look at the region number 1, the bottom bay contribution of Sweden in the freshwater discharge, you see a clear trend here. So in the north, it has been wetter, but you can't see it for the salinity in the Baltic Sea. These are data collected for the entire Baltic Sea, sea surface data, starting with 1920. There are actually some older data available, but we have excluded it in this article because it is then difficult to construct annual means. And you see clearly there's a pronounced multi-decadal variability with some imagination. You can see here a 30-year periodicity, but there's no trend in this. There is a trend since the 80s, yes, but no trend compared to the very historic earlier time data. But if we look then at not only the mean for the year and for the entire basin, but for the gradient, and this is the slide, the panel to the lower left. This is the gradient between the north and the south, so the gradient in sea surface salinity. You see statistically very weak, but there is a trend. And now I come back to the confidence levels. So there might be something that there is an upward trend in the gradient. That means the north is getting fresher compared to the south. Modeling has been used, and with models you can manipulate it. So you can manipulate the fresh water supply. And this has been done in the two right panels. So there are curves, the reference model, that is actually also the red curve here in the left, but you see now to the right, the sensitivity experiments. And if you focus on the blue one compared to the red one curve, then you see the red one is showing an increase in the gradient like the observation. But if you switch off the changes in runoff, so simply keep every year the same in runoff, there is a slight decreasing or no trend, no statistically significant trend in the record. So this is some evidence that this might be connected to the increase in freshwater supply in the north. Saltwater inflows is a very special topic. It has been also studied since decades. The famous record by Matthäus and Frank started in 1886, I think. That's the blue one. So the blue bars show the reconstruction, the earlier reconstruction of major Baltic inflows into the Baltic Sea. in the unit gigaton. But then people wondered why there is a decrease in the frequency, and this was attributed to the increase in freshwater, so the climate change, as we have discussed before. But the green curve actually show now a new reconstruction by moreholes, and it shows clearly that there is no trend. And what is the difference between the two records? Well, it's observational based, and in the first times, the observations are coming from a lightship, GZRF, in the entrance area of the Baltic Sea, and later on it was the Marnet station at Darsil, and this station changed the location. So there were the lower record is not homogeneous, whereas the green record actually take that into account. So no trend in saltwater inflows. Sea level, as you all know, is increasing, and this is a rather robust signal, 24 centimeters for the period that you're shown here. It is also possible to see that there is an acceleration, but this you cannot reconstruct from individual stations. You need to have a look and to apply statistical methods carefully for all the different stations. Then you can actually see an acceleration. So about the future, these are the projections in air temperature. The upper rows show winter and summer, and it is according to different warming levels, different emissions of greenhouse gases. In the world, RCP 2.6 to RCP 8.5. This is still based on the previous IPCC report. So we have not done these exercises for the CMAP 6, so the latest report. But actually, I can tell you when you compare it, the numbers are pretty much the same if you would have applied a downscaling to our region based on the latest IPCC report. The average air temperature change over our region, so the Baltic Sea region, is 1.5 in the 2.6 RCP scenario that corresponds to the Paris Agreement. And the most pessimistic agreement that people nowadays believe cannot happen, even if we follow some fossil fuel path into the future, is 4.3. So marine heat waves has been studied. They increase in number and the duration, especially in the coastal zone of the Baltic Sea. And please have always a look also in the Gulf of Finland of these maps. So also there, especially the southern and eastern coasts are affected by marine heat waves according to these modeling results. I will not show you the sea ice, but it is clear that there is the projections will show a shrinking and thinning of the Baltic Sea ice cover. But there's still some ice in the projections in the very north in the mean. So very mild ice winters will still occur. So the Baltic Sea projections do not suggest any ice-free Baltic Sea in the future, even in the most pessimistic scenario. And here's precipitation. So the north is getting wetter in winter, and also the south. That's very clear and a robust result. But in summer, it is the north where the signal is clear. In the south, it's a transition region between the drying and wettening signal. So there it's it's unclear. But in the overall, some river discharge is increasing. But the projections are widespread. So they are projected to increase between 2 and 22% in RCP 4.5 and 7 to 22% in RCP 8.5. Yeah, but so as I said, a large uncertainty here in the amount of the increase. And I will give you some comparison because that has discussed quite a lot in the past, what happens with salinity during the different assessments. We have the first assessment report. There we found a large spread. You see it in the right table, from 0 to 3.7 gram per kilogram decrease. And nowadays, actually, the projection show no change. What is the reason? The very first projection increased ensemble members that have a large increase in the west wind that contributes to the blocking. So decrease in the blocking of the freshwater outflow. So increase in salinity also from the wind. The river discharge numbers have not changed so much in time in the projections. They have been all the time uncertain. But then a new factor has been considered, the sea level rise. And even if you take moderate numbers of 0.5 meter into account, corresponding to the RCP 4.5 ensemble mean, you get then an almost compensation of the effect of river discharge, because there are no significant changes in the latest projections in wind speed. So the sea level will continue to rise, but there's a high uncertainty. I'm speeding up a little bit, and I'm going also over the uncertainty. So I hope that I could convince you that it is not clear what is happening with Baltic Sea salinity in the future. There are counteracting factors. It's the wind, it's the runoff, and the sea level rise. And obviously the wind, the mean wind and also the extreme winds are not changing. So it's the interplay between the rising sea level and the increase in the freshwater. And we do not know the outcome, who is winning in this projection game. Saltwater inflows obviously have not shown any change in the past. So this less saltwater inflows was due to inhomogeneous time records, this conclusion. So that's not true. To the contrary, there has been some projections that suggest a slight increase in saltwater inflows. And together with the sea level rise, more salt is actually transported into the Baltic Sea, which each of the inflows. More frequent storms, no, that is not supported. And the same with extreme sea levels. Of course, the mean sea level is increasing, and then the extremes are getting more extremes, but not due to an increase in the frequency of storms. Hypoxia, I have not talked about that. So the oxygen depletion, it's today record high. It will or will not decrease, we do not know, but this has nothing to do with climate change. There is obviously, and there's a new study around that shows that there is a substantial effect from the warming, from the past warming that contributed to the large-scale hypoxia in the Baltic Sea. But the dominant driver are the nutrient loads from land, so man-made actions in agriculture. And more cyanobacteria blooms, it depends as well very much from the nutrient loads and less from the warming, but it can be if the reductions are not as much as suggested by the Baltic Sea Action Plan, together with most pessimistic warming projections, there's an increase in cyanobacteria blooms.
Markus, could you please...
So my last slide. My last slide, that is the summary. You see here the errors, and I have not talked about that, but these are the dependency in the system affecting the difference. So what is really affecting by climate change which parameter? And you see a lot of the black arrows. This is the heat cycle, and the air temperature is affecting the cryosphere. That's very clear. And also the water temperature is affecting some of the biological parameters. But the other errors, there are much less. The blue one is from the water cycle and from the momentum flux, so the wind import. There are some errors that affect it, but the knowledge, although it is thinkable, is quite low about any significant changes. So please have a look at the article, then these dependencies are discussed into more detail. This is just to give you a glimpse from the fact sheet, what kind of information you can get. You can zoom into the Gulf of Finland and you will get in easy language the information about the different parameters here shown by symbols. So the thermometer, for instance, is the water temperature. Some information for stakeholders, what we expect from the projections. And I thank you very much for your attention. I thank very much the contributors of all the scientists to the Baltic Earth Assessment Report. And I thank all the contributors to the climate change fact sheets. Also there, more than 100 persons contributed. Thank you very much.
Thanks a lot, Markus, and many thanks to all speakers. We have now eaten up 6 minutes, almost 6 minutes of coffee break time, so we can't allow any questions at this stage. Unfortunately, what I could only wish is that drink faster and be back in time.
Thank you and bye-bye.
Saame, vot 5 minutit võib praegu võtta, ei ole midagi.
So, okay. Let us continue now this morning session, and now we are now a little bit behind the schedule, but anyway, I have one small announcement for those who belong to the scientific committee of the Gulf of Finland cooperation. Please, after this session, please remain here for a short time. We have a short discussion before the lunch. But now we go on. This session, my name is Kai Myrberg from Syke, from Helsinki. And this session is devoted to a very topical issue, which is a maritime spatial planning. And we start with the Russian presentation from Larissa Danilova and Andrei Lappo about the Russian MSP roadmap. So please, Larissa.
My name is Larissa Danilova. I represent Institute of Maritime Spatial Planning, Yermak Northwest, St. Petersburg, Russia. Thank you very much for the hostess, for the organizers, for this very nice possibility to present Russian MSP roadmap. And I'm very happy to see you all in person today, because we stay at home for 2 years, near 2 years now, and so it's a very nice possibility to visit Tallinn, visit Estonia. Thank you. If we speak about the maritime spatial planning, the Baltic Sea started this process 2 years ago, 10 years ago, nearly 10 years ago, and have very much progress in this direction, mostly in the European countries, including Finland and Estonia, and not so exciting progress in the Russian Federation due to other reasons. So the idea of the project capacity for MSP implemented under the international program Interreg Baltic Sea region was to the project is large itself, of course, but one of the goals was to facilitate Russian MSP and to promote MSP in Russia. So the output of our work is the first draft of the proposals for the action plan or roadmap for the promotion of maritime spatial planning in the Russian Federation. I will name it during my presentation Russian MSP roadmap to be a little bit shorter. Yes? The idea of MSP, as I said below, is very popular. That is very well known now and well made tool for spatial distribution of economic activities in the marine area, but still we don't have the common position what it is, because some name it marine spatial planning, some countries name it maritime spatial planning. So we have very different positions, very different national maritime policies and so on, but all with have the common vision on principles of MSP in Baltic, on of its main goals, and the mostly in this marine policy, the most what is that is the implementation of ecosystem-based approach, that is preservation of ecosystems of nature complexes and the rational use of the marine space and sustainable development of the marine economy. That is our common vision on MSP. Next slide, please. Okay, what we have in place now and what are the starting points for our project and for Russian MSP roadmap. Yes, we have HELCOM Baltic Sea Action Plan. It's in place, and now the new PSAP is adopted in the October of 2021 until the 2030 with the common goals in it. New MSP roadmap was adopted too together with PSAP. The capacity for MSP project platform gathered together the experts from all Baltic Sea countries, and with its aim to capitalize outcomes and findings of the previous MSP projects and processes of real planning in the Baltic countries. New WASAP long-term perspective up to 2040 is being developed currently, and Russian MSP roadmap is under finalization in December of 2021 and January 2022. The purpose of the roadmap is to develop proposals for the action plan to ensure the MSP improvement and implementation in the Russian Federation, and the cooperation of the Baltic Sea countries in the field of MSP carried out within the framework of a joint horizontal action of the international regional organizations HELCOM and WASAP, which created the conditions for accelerating the process of MSP in the Russian Federation. Next slide, please. Okay, that is what we have in Russia. Of course, we have international framework, that is UNESCO guidelines on MSP, PSAP, Baltic Region MSP Roadmap, and bilateral cooperation programs with Sweden, Finland, Estonia, Norway, and so on, to ensure the ecological safety of marine economic activities. And what is new, very new for Russia, not for the Baltic, but for Russia, that is Black Sea Strategic Research and Innovation Agenda, which is adopted with all Black Sea countries, and one of its goals and one of its actions is transboundary MSP methodology. What is national state of play and framework? We have maritime doctrine of the Russian Federation, decree of the President on the improvement of maritime activities, state program environmental protection, marine strategy, and national project ecology. Next slide, please. Official support. That is the most difficult question in this presentation, because we still don't have the responsible ministry in Russia who is responsible for MSP and for framework development, for planning process, for adoption, and so on. And we don't have MSP that can say that we support ministry who can say that it support MSP, because rather ministries are responsible for other things in the marine area and in marine economy, and they are responsible for their work. Yes, and they are limited with their responsibilities. So the Ministry of Natural Resources and Ecology of the Russian Federation supports the implementation of the ecosystem-based approach to marine and coastal management, as well as for the territorial and so on. Ministry of Foreign Affairs of the Russian Federation is very supportive for international cooperation in the field of integrated marine and coastal management and blue economy development. Ministry of Economy is supporting marine blue economy development. Marine Board under the government of the Russian Federation supports the development and improvement of marine environmental management tools and education of marine staff. So we have a lot of supporting governmental bodies, but we still don't have the body which is responsible for MSP itself. The roadmap is developed by the Russian partners of the project Capacity for MSP, that is my institute, Institute of Maritime Spatial Planning, Yermak Northwest, and the Russian State Hydrometeorological University. And we gathered our capacity, our experience, expertise, and so on. During this project, the implementation of the project, we developed together the Russian supporting platform in the coastal regions and of Russia and in Moscow, there are a lot of organizations that supports MSP, that provided roundtables, conferences, facilitated discussion in their regions and so on. Next slide, please. Here is the actions of the project. I will not say a lot of it because I will say in the next slide, I will show you all these actions. Next slide, please. The first is the gathering of data and information about Russian seas, overview of Russian seas. As you know, Russia have a lot of seas and rather directions, and significant total area of marine areas, more than 8 and 6 billion kilometers. The length of the coastline is 60,000 kilometers, and we have significantly different conditions of the seas. 13 seas, Caspian Sea, and 3 oceans. That is a lot, and that is the challenge, because they have very different natural conditions. The second challenge is that the coastal regions' borders don't match catchment areas. So sometimes it is better to develop a maritime spatial plan for the region, for the sea belongs to the coastal region, and sometimes it is more convenient to think about the enlarged area, Arctic, for example, or Far East, with some specificity, with one specific economic activities or natural conditions. Next slide, please. Okay, that is the wide stakeholder dialogue, and the project capacity for MSP gave us that possibility to speak with stakeholders. We arranged as a whole 13 workshops and conferences and roundtables and so on in all marine directions of Russian Federation, and we presented MSP on a lot of conferences in Black Sea, Baltic Sea, and so on. So there were 13 sessions and 10 presentations on rather another events. Next slide, please. The survey was made in the previous summer. There were 450 inquiries, and we got 219 answers from very different stakeholders. And we see as a result that more of them supports MSP and want their regions to have the pilot MSP plans. The main kinds of maritime activities were defined. You can see them on the slide. I will not speak a lot about it. Of course, the first place is shipping, and the second is fishing, and then the marine tourism. What is really interesting here is that hydrocarbon production is on the last place, and that's not how it is. Recipients think that it's on the last place, with only 6% of how the recipients who mentioned them. Next slide, please. Okay, and that is much more important as for me. That is maritime activities that caused public concerns. And on the first place is nature protection, and on the second is industrial use. Next slide, please. I will try to be a little bit fast. Okay, that is the main pillars of Russian MSP roadmap. Next slide, please. First pillar is institutional arrangements, because we need to have legislation, we have framework for it. Next slide, please. The second pillar is about the arrangements and about responsibilities of the coastal regions and the national, federal responsibilities. Second slide, next slide. Okay, that is scientific and technical measures, because we need the methodology, not only for MSP, but for different its different activities. We have a lot of work for scientific people. Ecosystem-based approach is the first one, what we need to develop. Next slide, please. Fourth slide is about education and training, because the capacity and the staff, that is the basis of planning process. Next slide, please. And the fifth one is MSPs for Russian regions and enlarged MSPs and so on. Next slide, please. That is the flow chart of the process. If you can see, the start is the assignment of Marine Board under the government of the Russian Federation. Now this project roadmap is submitted to the Scientific and Expert Council of the Marine Board. And so we got a lot of reviews and a lot of comments. And now we are on the second stage of, we try to analyze all this and work with all this. And the duration of this from the very beginning will be from 5 until 7 years. Next slide, please. I will not focus on these cases on pilot MSPs. We made them, and my colleague will have presentation tomorrow on concrete, very specific case of maritime functional zoning as the tool to implement ecosystem-based approach. Yes, next slide, please. Yes, and this one too. Okay, the roadmap have explanatory note, of course. You can see its content. It's quite extensive. And what is what we made at the last stage of the development of explanatory note, we produced something like FAQ. We answered on the very easy questions of those who is not involved in MSP. And sometimes they seems to be fun. But in reality, that is very serious and very important to provide these answers on this question. Next one, please. That is our team. That's not all who worked on this project are mentioned here. In reality, our people who are involved in the development of the roadmap is much wider. Here are shown the main persons. Next one, please. Okay, the next steps and the plans for the international cooperation. Now, as I said, this draft is submitted to the Scientific Expert Council of the Marine Board. And after the first round of discussion, the draft will be amended and completed, and then translated into English. We have plans to develop the working group in the Marine Board to promote MSP in Russia. The discussion now is very heated, but it started, and that is good. And what we want to make in the next Gulf of Finland Day, I hope to have some common picture of the Gulf of Finland together Russia, Finland, and Estonian science and planners, and to have some kind of concept with common vision. Thank you. That's all.
Thank you very much for this interesting presentation. Unfortunately, we are quite much late from the schedule, so I hope that Larissa and Andre will be here, so please discuss with them later on. And now we go on to the next talk, which is by Riku Varjopuro from Finnish Environment Institute about Finland's Maritime Spatial Planning 2030. So I hope that we will find Riku somewhere in the internet.
Yes. Hello. Can you confirm that you hear me?
Yes.
Good. And do you see my slides? Good. Okay, yes. My name is Riku Varjopuro. I'm from the Finnish Environment Institute, and unfortunately, I'm not there with you in Tallinn to give this presentation. So a bit last-minute decision that who will actually give this presentation, as Finland's Maritime Spatial Plan is formally represented by the Ministry of the Environment, the Spatial Planning Unit in this kind of international context, but unfortunately, no one from the MSP team at the Ministry could participate in this event. So I'm giving this presentation on behalf of the Ministry. So I'm giving you sort of the overview of Finland's Maritime Spatial Plan 2030, the main principles and about the process. And Finland's MSP plan is implementing the EU directive on MSP. The directive came into force in 2014, and it was transposed to Finland's legislation to Land Use and Building Act in 2016, and in that process of transposing, it was also decided some key principles and planning areas and so forth. And on a general level, the purpose of the Finland's MSP is to promote sustainable blue economy, but the law also states that the MSP should support achievement of good environmental status of the sea areas. And then some key sectors were identified in that process to be included in the plan. And it's also just decided that national defense needs will be highlighted in the planning process. And then there was some principles. It was agreed that Finland's MSP will apply the ecosystem-based approach and also pay special attention to land-sea interactions, and also to pay attention to characteristics of marine areas of different sea areas in Finland. And of course, in comparison to, for instance, to Russian sea areas, the Finnish sea areas are quite homogenic, but still it makes sense to look on a more detailed level and to highlight what is special about different sea areas also in Finland. And then it was decided that there will be 3 MSP planning areas in Finland on the mainland sea areas, and then Åland Islands will produce their own MSP plan because they have their own planning law and mandate to do that. And for the mainland Finland, that I will focus on in this presentation, the 3 planning areas are shown with red borders on the map, and the planning mandate was given to regional councils that already before that had a mandate to do a spatial plan on land and also in territorial sea areas. So it was quite logical to give them the authority for MSP planning. But then it was also decided that it's not only for each regional councils area separately, but they were combined in 2 or 4 regional councils will do the plan together. And the planning MSP plan will cover all sea areas from the shoreline to territorial sea and the exclusive economic zone, the same area as the Marine Strategy Framework Directive implementation. And in this connection, the regional councils were also given a mandate to produce MSP plan for the exclusive economic zone, which was a change in the previous mandate. The planning process, it started effectively in 2017 first with analysis of the current state and work on future scenarios. And then there was a public hearing on the findings so far, and also on the process. And then the actual plan making started in 2019, and the draft plan was for public hearing in spring 2020, and it was finalized during the autumn and then approved by all the regional councils. The last approval was in December 2020. So the plan is now 1 year old. And then the next step in the planning process, because of course the MSP planning is a continuous process. The next step will be monitoring and evaluation, and it will actually start beginning of the next year in 2022, and then gradually move towards the next plan review. And here's one important point to understand about Finland's approach to spatial planning at sea areas. There are actually 3 levels of spatial planning at sea. The local level is through municipalities' master plans, and they have a mandate to plan all the territorial waters in the municipal area. And then the next level is regional land use planning level, that also has a mandate to cover territorial waters, and this is done by regional councils, and they cover sea area of several municipalities in the region. And then there is the third level, the actual maritime spatial plan, which covers territorial waters and the exclusive economic zone. But this plan is strategic, and as a difference to the 2 other planning levels that are legally binding and stronger, that has stronger legal basis. MSP plan in Finland is strategic, and it's not in a hierarchical position to regional or municipal planning. But the idea is that taking this broader view and this strategic approach, it can inform the regional and municipal planning when these plans are then later updated. And then to the actual plan. Yes, on the map you can see an example from the Gulf of Finland MSP plan, and there's 16 different types of planning markings, and then some other information is also presented on the planning map. And what's also interesting and a bit different from many countries MSPs is really the land sea interaction is very clearly addressed in the plan, and many of the planning markings they extend to land. And of course this is logical, because this was done by same people and same authorities that also do land use planning, and so in this respect one can expect quite nice continuum from sea to land and back. And then some principles in the planning were that none of the uses were really prioritized. In the planning process, all maritime actors were tried to give an equal standing. And then another important point is that the plan, it indicates areas and connections of significance, and especially with potential, it sort of signals future potentials rather than limits very much of future activities. So it's more about opportunities than excluding some activities. And then one important aspect also in Finland's MSP plan is that it is presented only in a digital format. It's on the website only, and this is possibly the first policy in Finland that is published only in digital format. And if you want to know more about Finland's MSP, I really recommend you to go to see and study its on the website. It's there in Finnish, Swedish, and English. All the material is in 3 languages, and here you can see the websites and and the website is really rich in information. There are some, but the maritime special planning section is about principles and law and such. But then, for instance, scenario work is presented very nicely and very comprehensively. There were 3 alternative futures were designed, and then the scenario process looked at how these 3 alternative future developments, how they would look on these planning regions, but also for different sectors. And then visions work was more about setting targets to be achieved and presenting sector-specific roadmaps for 2030. And then there's the actual maritime special plan, obviously, and it's quite well also the planning principles and planning evidence is presented there. And then impact assessment, that's also quite rich. It's there is strategic environmental assessment part or similar kind of assessment was done, but it also presents, for instance, how different sectors, what sort of impact mechanisms one could expect, and also what kind of factors may intervene achievement of these different goals set for these sectors through the plan. And this sort of sets the basis for future monitoring and evaluation process. So I think I will stop here, and I will recommend you to go to the website to learn more of Finland's plan. Thank you very much.
Thank you, Riku, very much for the interesting presentation, and I hope that you can contact Riku in case of any further questions. So we will go on now to Estonia, MSP in Estonia, and next presentation is practical experiences from the process by Elleri Kautlemba. So please. Tämä räägib ilmselt.
Hello, everybody. I'm sorry for that. Well, my name is Elleri Kautlemba, and today I will introduce you practical experience from the process. I'm working in Ministry of Finance. I am advisor of Special Planning Department. Introduction, I will show you our marine areas. This is Estonian marine area. We have territorial sea and we have exclusive economic zone. And we are planning that area right now. Except for 2 areas, around Hiiumaa, we already have plan, and here in Pärnu Bay also have plan. Their plans are, and there we don't planning right now. Yes, in around Hiiumaa we don't have offshore wind energy plan because a few years ago our National Court of Estonia established that part of what regulated offshore wind energy. We don't know yet what we are going to do with this team. Are we do new thematic plan or not? We are right now thinking about it. Our MSP have own web page. There is a web map where you can zoom in and zoom out and click in and off different layers. There is also different documents like basic analysis and plan and environment impact assessment materials and so on. Here is the address, and if you want, you can go. There is materials also in English. Our MSP is a strategical special development document at the state level, where primary focus is combined uses and new uses. And we have based of environmental considerations and the best available technologies. We have done many different analyses like seals, bats, birds, and so on. Also, we have economical model where is added ecosystem service map layers, and there is also cumulative impact model. This model name is Plan Wise for Blue. The author is Jonne Kotta, who is also today here, as much as I know. And one big team, we have been offshore wind energy visual impacts. And that's why we analyze this team also, and we have guideline to the next phase. Our MSP gives guidelines and conditions to the next phase. Guidelines are recommendations, but conditions, these are mandatory requirements set by the plan. Here is our list of marine uses. These topics are all included in the plan. Here you can see traditional uses like fishing or marine transport or seabed infrastructure or marine tourism and recreation. But here is also new uses like agriculture, like fish farming, shellfish and algae farming, and also renewable energy. Basically, it is offshore wind energy. For all these uses we have in the MSP are guidelines and conditions. Some of them have also special output. Here you can see special output have offshore wind energy areas. We have 3 different areas for that. We have here marine transport lines, and also there is fishing. Fishermen can fish everywhere. And yes, we have pink areas here are our national defense areas, and these blue bubbles are our ports. We have extended impact assessment. It means that we don't have traditional impact assessments where assessment is natural environment centered, but we have, or in our CAA, we impact also, or we assess also social impacts, like also including health impacts, culture impacts, and economic impacts. And I think extended impact assessment is one key of success or success key, because we have been so many questions. So many questions, and I think we can't answer them if we didn't do extended impact assessment. And the other success, I think a good solution was board-based expertise. We have in this process so many different experts who helped us. We wanted that our plan will be ecosystem-based approach, but at the same time we wanted that it will be economically sustainable. And that's why we have been so many different experts from nature part and also economic part. Here you can see our timeline. We started May 2070, and we hope that we adopt this plan next year, January 22. It was 5 years planning, and we have been a lot of public consultations. We have been more public consultations than our planning act insist, but I think it was necessary to make a good plan. And what we learn? We learned that have to talk with people and then again talk and again and again. And we have to give them opportunity to ask directly from you, because covered topics usually needs clarifications. And it is in national consultation process and also internationals. We have done a lot of work closely with different stakeholders, and we have do it again and again and again. And they ask the same questions many times, and now they have the answers. And right now we are in a situation where all stakeholders are satisfied. I think it's like a little bit like I didn't expect that, but now our natural NGOs, they are satisfied. They are telling that it's a good solution, it's a good plan, because for birds and bats, the migration corridors are free, fish they can live healthy and well. Also seals, they have important are free and protected. What else? Also, we learned that translations are necessary. Summaries are not enough. But if you don't have translations, you have only summaries, then you have many questions and you have the clarification, many things. But it's much easier to understand, because these materials are not easy to understand, and it's much easier if you have all materials translated, and then easier submit a different proposal also. And also we learned that if you have problem, ask your neighbors. Believe me, they have the same problems, and maybe they already have some answers or good solutions. We made different workshop with Germany colleagues and also Swedish and Finnish colleagues, and yes, we have got a lot of good ideas how to deal with different topics. For example, we had a question, what kind of environmental data we need, or what kind of conditions we need if we want to plan offshore wind energy. And yes, they had good ideas. And as I already told, extended impact assessment helped us to justify the solutions. Yeah, it was really helped, and I success it for you too. Well, that is our story. I understand that we have we have a little bit busy, but thank you, and I will wish you smart planning. And if you have questions, I don't know, have we time for that? If you have questions, you can always write to us and or call us, and if we know, we will help. Thank you.
Thank you, Eleri, very much for this very informative presentation of the situation in Estonia. And now we have to rush again to the next talk, which is given by Kevin Parnell together with Tarmo Soomere, a geomorphic perspective on paradigms, history and coastal spatial planning in the Gulf of Finland. And we know, as a member of the parliament, Ms. Anneli Akkerman told this morning, this is a very topical issue, the coastal spatial planning in Estonian parliament today. So, please.
Thank you. Okay. Thank you very much. What I'm going to be talking about today are paradigms, sets of ideas that influence our thinking. And there is absolutely no doubt that prevailing paradigms influence how we undertake environmental management. I'm going to start when I was a master's student in the early 1980s, when in thinking about coastal management, thinking was dominated by coastal hazards. And I don't know how many versions of this formula I saw as a student, the coastal hazard zone formula, where a line was drawn on a map. And we still see elements of that around today. Then, after the Rio summit in 1992, integrated coastal zone management became the buzz term and the way things were thought about. And I'm not going to go over what it is, we all know about those things, but I just want to highlight the last two sentences on this slide, where there has been a lot of literature around saying that, well, it's a great idea, but it hasn't really worked. Maybe it's just too complicated. This last one, the participative bottom-up approach of contemporary European ICZM, ineffectual and unsustainable. Then with climate change, we went to adaptation as a paradigm. And right around the world, we find organisations within government set up to undertake and coordinate coastal adaptation approaches. And in many ways, I think we are still in this paradigm today. What underlies these different paradigms is one theme, and that relates to property rights. Underlying these themes are the right to protect property, private property rights versus public property rights, and also who is going to pay for these things, and indeed just the right to protect property. And I'm just going to use a very quick example of seawalls, which I think indicates the problem of all these paradigms quite nicely. Most places have an entrenched right to protect your private land, but we also want to protect our coastlines for private uses. And where coasts are eroding, these two views of the world, or our views of coasts, are entirely incompatible. And I use this cartoon just to show that. Here we've got a plan view and a profile view of beaches with property behind it. And one of the owners exercises a right to build a seawall. And you can see that case in the middle. Well, if this is an eroding coast, what happens? On the top and the bottom, we see the beach just retreating. In the middle, we see the profile retreating, which where the seawall is simply results in the level of the beach going down. So what we end up with is a beach at the top and bottom, but in a different location. In the middle, we end up with no beach at all. That's just how it works. We all know that. And we often hear the term beach protection, but what is beach protection? It's not beach protection, but asset protection. Just a very quick local example of that. Here we see a seawall looking after a building. And what I want to point out here is that in this location, people can still go and use the beach. Here, they will get wet if they try to lie on the beach and sunbathe. So most of us agree that if a beach is eroding, a properly built seawall will protect assets, and I emphasize properly built there. Few countries have the resources in the light of what's going to happen into the future of protecting large amounts of coastline anyway, and beaches will remain healthy in the future if they are allowed to be ambulatory or are allowed to move. So let's just return to the Gulf of Finland, and I just highlight this book that came out a few years ago now. And first of all, Finland, what problem? It is interesting to me that Finland is the only country in Europe that's not represented in that book, and I think for very good reason. I'm not trying to downplay issues that they have, but with generally hard coasts and still a little bit of isostatic uplift, the problem is certainly a lot less than many other countries face. In terms of Russia, I admit that I don't know very much about the Russian Gulf of Finland, and I certainly would welcome collaboration on that. But in Estonia, I think the situation right now is quite good because of tradition of not building near the coast, its history, or an act, the Nature Conservation Act, which in my opinion is a very good one. Coastal buffers or setbacks are generally large, but I will suggest that this may be changing. Why is this? Well, there's been a lot written on history, and of course, during the period 40s through 90s, the coastal zone was very much a no-go zone in terms of certain activities. And you will find a number of papers in the literature exploring that. But the result is that the coastal strip is relatively devoid of structures. And when I came to Estonia first a few years back, this made me very happy indeed. We also have the Baltic Greenbelt Initiative, part of the European Greenbelt Initiative. It's there, but there's not a lot of formal application that I've found in the planning process. But moving on a bit and looking as a bit of an outsider here, many countries and people look with envy at places that, for whatever reason, have a largely undeveloped coastal area with wide setbacks. And Estonia is certainly, right now, one of these. But in the last week or so, there have been some unfortunate, in my opinion, developments. And this is just a translation of an article that appeared in a number of the newspapers in Estonia over the last few days. Now, the Nature Conservation Act 2004 in Estonia has established in the coastal area very wide setbacks. On a world scale, these are very wide setbacks, from 200 meters in some areas, 100 meters in some areas, and this explains that situation that I just mentioned. But just earlier this month, a bill was signed. That doesn't mean it's law, it's just starting a process of consideration that would leave only a 20-meter protection zone everywhere in Estonia, which can be altered by local governments. Now, to me, this is not the time, with future climate change, sea level rise, and other things that are going on, to even be considering such a change. And we certainly must use the historical advantages that exist, given the country's history, and given what may have been a very fortunate passing of an act a number of years ago. Now, returning to paradigms, we have seen some successes in coastal management, but we keep trying to integrate, reconcile, and adapt, and I'm going to suggest that it's time for a paradigm shift. This is the sustainability model. This is the model that I'm going to go into. Now, I just want to point out that there are other people thinking this way, or thinking in different ways, and I just point out this book by our colleague Anders Omstedt. It's not a rights of nature approach, but if you haven't seen that book, I would really encourage you to have a look at it, because Anders in this has really just tried to introduce a different way of thinking about coastal management. I don't necessarily agree with everything he says, but it's great to see these scientists, well-respected scientists, now starting to think in different ways. Now, I do want to promote, or at least get you thinking about, the Earth jurisprudence, rights of nature approach, which started appearing in the literature in the 2010s. And it's a legal theory that describes environments as having inherent legal rights. It that is now reasonably well established in a number of places. A number of countries now have laws that in part encompass these views. The one that I'm most familiar with is the case in New Zealand of a river. It's the Whanganui River, that in legislation, for legal purposes, is now a person. This is the idea behind the rights of nature approach. Now, you can see that this approach is entering the scientific literature as well, but it's mainly involved in the management and the legal aspects of this particular river. And this picture here, from a legal perspective, is a picture of the river. That there is the river from a legal perspective. She is one of two, in fact, guardians that represent the rights of the river in the legal system. A different way of thinking about things. Now, in Europe, the rights of nature approach is quite new. And 2019, an initial conference, and 2 reports here sponsored by different elements of the European Union. So the thoughts are there, but it hasn't really progressed very far at all. So instead of a summary, I'm going to ask some summary questions. Firstly, is there a way forward for coastal spatial planning that goes about this approach of trying to integrate knowledge, integrate viewpoints, or do we really need to make a fundamental change in the way we think about things? How do we ensure the maintenance of historical and natural advantages where they exist? We can't go backwards, and I'm afraid that there is some thinking in Estonia right now where that is maybe starting to happen. Quite specifically, should a beach, insert your favorite type of environment, have legal right to exist, function, migrate, even when its functioning infringes on private property rights? Does the environment itself have those rights over the rights of ownership? And I'm not suggesting it necessarily is, but is the rights of nature approach a possible way forward here? That's all I want to say. Thank you very much.
Thank you, Kevin, very much. Now we have really time for some questions because Kevin was giving this talk in 10 minutes. Very good example to all of us. So please, questions to Kevin. It was very clear presentation. I would like to ask that what do you think that is Estonian, maybe you are not an Estonian, but maybe it's better to ask from you that do you think that the Estonian government and the parliament will agree on what you said, or do they disagree with you?
I'm afraid I'm not the right person to ask that. I really don't know. I just was a little bit taken aback when I saw this reporting. I have no idea where this is going to end up. I certainly have my views as to where it should end up, but that's not up to me.
Is there any other comments to this talk? Well, Kevin will be here, so all of you who are interested in coastal processes, I could say that Kevin is a really famous man for this activity, so please discuss with him during the lunch break and coffee break. So thank you very much, Kevin.
Thank you.
And then we have the last presentation for this section, and it's given by Tatiana Eremina and her colleagues. Tools for implementation of ecosystem-based approach in maritime spatial planning in the eastern part of the Gulf of Finland. So. But you are not Tatiana.
Yes, it was some misunderstanding, so it was me who asked who's supposed to present. Yes,
Aha. So you can introduce yourself then. Thank you.
Everyone, I would like to present our presentation from Russian State Hydrometeorological University. I'm Vera Semyoshenkova, and it's our presentation. Tools for the implementation of the ecosystem-based approach into maritime spatial planning of Russian coastal waters on the Baltic Sea. One of the main principles for the implementation of marine special plans is ecosystem approach. To implement the ecosystem approach in marine special planning, which is being developed for the coastal Russian waters of the Baltic Sea within the framework of the capacity for MSP project, scientific tools are needed to generalize, analyze, and predict changes to ensure a good ecological state of the marine environment. Tools for the implementation of ecosystem-based management is the relevant legal norms aimed at the conservation of the ecosystem and its sustainable use, which must be considered when drawing up plans in accordance with the national legislation and with the obligations of the state to implement the international conventions. So these tools include indexing maps of biodiversity, maps of areas of the main technosphere load on the ecosystems, maps of high vulnerability of coastal ecosystems to anthropogenic impact, and 3D modeling of ecosystems for climate change scenario and nutrient load reduction according to a Baltic Sea action plan. Sorry. I don't know, okay. You can't see the slide, I don't know what, let's continue. I should say that the eastern part of the Gulf of Finland is a zone of active human economic activity. So for many decades, various scale hydraulic engineering works have been carried out in the coastal zones of the eastern part of the Gulf of Finland. So dredging of existing and construction of new fairways, dumping of soil into underwater dams, reclamation of artificial coastal areas to expand urban development zones, and other purposes, construction of port complexes, and so on. So on this slide you can see the recreational load on coastal biotopes, and so there are other coastal zones marked with red. This is overwhelming activity, high level recreational load on the with orange. So yellow shows us the middle level load, and low level load in green. So here the diversity of coastal biotopes on the eastern part of the Gulf of Finland is presented. The coastal biotopes are diverse enough to support a large set of different biological communities. At this slide you can see the water bird colonies on the left and stopping site on the overflights in the right, in the eastern part of the Gulf of Finland. At these slides, the routes of the spring on the left and autumn on the right flights of birds presented. At this slide, the key biotopes of the grey seal and Baltic ringed seal are presented, so for the mammals. Okay, so. At this slide, there is a distribution of animals listed in the Red Book of the Kaliningrad region. This slide is another example of sensitivity maps which are developed under this project, so not only for the eastern part of the Gulf of Finland, but also for the southern eastern part of the Gulf of Finland, particularly for the Kaliningrad region. So here we can see three statuses. So first status, this is the species which are under threat of disappearance, status to the decreasing species, and 3 rare species. At this slide you can see the habitats of migration birds and wintering birds in the coastal zone of the Russian sector of the southeastern part of the Baltic Sea. Here the protected area on the left and possible marine protection zones on the right, adjacent to specially protected natural territories in the coastal zone of Kaliningrad, Wislinsky Bay are presented. So the satellite observations also were used to analyze the climate, sea surface temperature. As the recent studies demonstrate, and also it has been already stated today, that for the last 30 years we can observe the increase of the temperature of the Baltic Sea. So if to consider all months, it's about 1-2 degrees, and considering July to September is on about 3-5 degrees. So it's very significant for the Baltic Sea. So using the 3D eco-hydrodynamic model, St. Petersburg Baltic Sea ecosystem model, we can analyze the prediction of marine ecosystem in future. And for the analyzing the scenarios, the simulation of scenarios, the following conditions were considered. So the period of calculation is about 100 years. Scenario of CO2 emission, A1B, global climate model, regional climate model, and phosphorus and nitrogen reduction according to Baltic Sea Action Plan. So here we can see some results of this. Annual average nutrients in the eastern part of the Gulf of Finland in the future climate under various external laws. So we can see the reference and predicted values. So if we take measures, if we follow measures to reduce the inflow with river runoff and from point sources of nutrients load in the Gulf of Finland, this will lead to a decrease in the concentrations of mineral nitrogen and phosphorus in all three identified areas of the eastern part of the Gulf of Finland, and in general, a decrease of eutrophication in the bay as a whole. Also, another mapping is the location of fishing areas with indicator areas near the northern coast of the Gulf of Finland. So, based on model assessment of changes in the state of the environment of the bay, fishing areas can be allocated for the purposes of industrial fishing, coastal fishing, and commercial fishing, farming, aquaculture. And the main conclusions are that scientific tools for the implementation of the ecosystem approach in the maritime special planning for the Russian coastal waters of the Baltic are quite well developed, and a legislative framework is needed for the introduction of an ecosystem approach in the implementation of maritime special planning. So the ecosystem approach should be considered and used for the planners and decision makers. Thank you very much.
Thank you very much. Thank you very much. Now, if there is some quick question, we can still take it. I asked you then to discuss with the authors of this paper later on, maybe during the coffee breaks. And now we have a lunch break until 2 o'clock, so we are more or less in time. And I asked those people who are members of the steering committee, the scientific steering committee, to stay here for a few minutes, and then after that everybody is happy to have a lunch, and then we will continue in about 58 minutes. The session is closed. Thank you.
Ympäristön roskaantuminen on kasvava ongelma kaikkialla maailmassa. Myös Itämeri ja sen itäisin osa, Suomenlahti, kärsii roskaantumisesta. Suomenlahti on vilkkaasti liikennöity merialue, jonka valuma-alueella asuu yli 10 miljoonaa ihmistä. Roskia päätyy meriympäristöön etenkin rannikkokaupungeista, joista suurimmat ovat Pietari, Helsinki ja Tallinna, mutta niitä kulkeutuu mereen jokien mukana myös kauempaa sisämaasta. Suurin osa meressä olevasta roskasta on muovia. Muovijätettä päätyy mereen maalta, esimerkiksi rakentamisesta ja tahallisesta roskaamisesta, mutta myös mereltä, kuten kalastuksesta ja meriliikenteestä. Suurimmat roskien lähteet vaihtelevat alueittain.
Источников, конечно же, много, их идентифицировать сложно, но все равно это все виды человеческой деятельности. Это, конечно же, свалки, нелегальные свалки, с которых может поступать мусор, может вымываться, например, дождями или какими-то атмосферными явлениями. Сточные воды, где нет таких продвинутых очистных сооружений. Также это, конечно, сами туристы, которые приезжают на пляж и оставляют, например, сигаретные окурки.
Muovi on hyvin kestävä materiaali, jonka hajoaminen luonnossa on hidasta. Merestä löytyykin yhä roskia, jotka on heitetty sinne vuosikymmeniä sitten. Ajan saatossa isompi muoviroska hapertuu ja murustuu pieniksi mikromuoveiksi, eli alle 5 mm kokoisiksi muovihippusiksi. Lisäksi mikromuoveja vapautuu esimerkiksi keinokuituvaatteista, kosmetiikasta ja tieliikenteestä.
А есть так называемый настоящий микропластик, все, что менее 1 миллиметра. С этим микропластиком все гораздо сложнее, его сложнее найти в водной среде, да, в почве. Для того, чтобы его там найти, нужно специализированное оборудование, серьезные лабораторные процедуры обработки проб и их анализа. Именно вот эти частицы менее 1 миллиметра уже микронного диапазона, то есть там 500, 100 и меньше микрон, вот именно они представляют опасность для живого организма, и именно их изучение направлено на основные исследования в мире.
Suomenlahden rantavaltioiden, eli Suomen, Viron ja Venäjän tutkijat selvittävät mikromuovin runsautta keräämällä näytteitä meren eri osista. Tutkimus vaatii kansainvälistä yhteistyötä biologien, kemistien, fyysikoiden ja monien muiden eri alojen osaajien kanssa.
Mikromuovit ja merten roskaantuminen on aika uusi ongelma ja me ei ole tiedetty, että mikä tilanne meillä meressä on. Ja vaan seurannoilla me voidaan nähdä, että mistä me löydetään eniten mikromuoveja ja kuinka se tilanne meressä muuttuu.
Roskaantumisen seurantaa on tärkeää tehdä säännöllisesti ja pitkäaikaisesti, jotta erotetaan, onko roskaantumista vähentävillä toimenpiteillä vaikutusta meren tilaan. Kartoituksissa on myös selvinnyt, että mikromuovit ovat runsaimmillaan rannikoilla, mikä kertoo maalta tulevasta kuormituksesta.
No meidän seurannoilla ja kenttänäytteenotoilla on saatu selville, että mikromuoveja löytyy meren pintakerroksesta ja tuolta eri vesipetsaan osista. Mikromuoveja on myös tuolla merenpohjan sedimentissä ja myös hyvin monenlaisissa eliöissä. Että oikeastaan kaikissa näytteissä, mitä me ollaan otettu, niin on löytynyt mikromuoveja, muun muassa simpukoista ja kaloista.
Kaikki kerätyt näytteet vaativat pitkän käsittelyn laboratoriossa. Kun mikromuovit on saatu eristettyä näytteistä, niiden kokoa ja materiaalia voidaan tutkia tarkemmin mikroskoopilla. Vaikka suurikokoisten roskien haitat eläimille tunnetaan jo melko hyvin, on tietämys mikromuovien vaikutuksista vielä puutteellista.
Väga tähtis uurida, miks mikroplast on ohtlik loomadele ja elusorganismidele. See on kahjulik sellegipoolest, et sisaldab lisandeid ja absorbeerib kemikaale enda pindadele veest. Ta võib absorbeerida raskmetalle, kahjulikke orgaanilisi aineid ja nagu pestitsiidid ja herbitsiidid näiteks. Need lisandid mõjutavad loomade hormonaalset süsteemi ja tervist tervikuna.
Suomenlahden molemmin puolin tehdyissä kartoituksissa on saatu samansuuntaisia tuloksia eläinten sisältämistä mikromuoveista.
Leidsime, et põhjalähedased kalad nagu lestad sisaldavad rohkem mikroplasti võrreldes pelaagiliste kaladega, sellistega nagu kilu ja räim. Ja iga 5. põhjalähedane kala sisaldas mikroplasti, iga 15. pelaagiline kala ka sisaldas mikroplasti. Me jätkame need uuringud edasi teistes projektides, kuna see teema on väga aktuaalne ja väga tähtis.
Jotta meriroskaongelmaan voidaan vaikuttaa, tarvitaan tutkimustietoa. Sekä tutkijoiden että kansalaisten keräämää ja tuottamaa tietoa käytetään apuna, kun etsitään keinoja roskaantumisen vähentämiseen. Esimerkiksi tietoa rantojen roskista on onnistuneesti käytetty ei ainoastaan Suomenlahden, vaan koko Euroopan merialueiden roskaantumisen ehkäisyssä.
Rantaroskaseuranta antaa viranomaisille ja päättäjille tärkeää tietoa rannoilta löytyvän roskan määrästä ja laadusta. EU:n kertakäyttömuovidirektiivi on hyvä esimerkki siitä, miten tätä tutkimustietoa hyödynnetään. Direktiivin tavoitteena on vähentää muovituotteiden ympäristövaikutuksia ja sen rajoitukset kohdistettiin erityisesti niihin roskatyyppeihin, joita yleisemmin löytyy eurooppalaisilta rannoilta, kuten take-away-ruokien pakkauksiin, kertakäyttöisiin ruokailuvälineisiin ja filtterisavukkeisiin. Rajoittamalla eniten ympäristöön päätyvien tuotteiden käyttöä saadaan aikaan mahdollisimman kattava vaikutus.
Roskien poistaminen merestä on äärimmäisen vaikeaa, jopa mahdotonta. Siksi on tärkeää toimia siten, etteivät roskat koskaan päätyisi mereen. Tutkijoiden ja päättäjien lisäksi me kaikki voimme omalta osaltamme vaikuttaa siihen, että oma lähiympäristömme ja siihen yhteydessä oleva Suomenlahti pysyy puhtaana. Millaisen lupauksen sinä voit tehdä yhteisen meremme puolesta?
Lupaukseni on vähentää yksityisautoilua.
Я призываю отказаться от пластиковых пакетов, за продуктами ходить со своими тканными мешочками.
Käies üles maha visatud prügid.
Lupaan vähendää keinokuituja vaatteissa.
Minu laps kasutab korduvkasutatavaid mähkmeid.
Я стараюсь, конечно, в своей жизни дома разделять мусор, приучать к этому детей.
Minul on väga lihtne sorteerida, kuna me elame eramajas ja me ei saa isegi komposteerida. Et biojäätmeid komposteerime, pakendid paneme suurde plastikakotti, mille anname tasuta ära, metalli viime kokkuostu ja puidu põletame ahjus.
Lupaan kierrättää muoviroskat.
С определенной периодичностью стараюсь ездить на работу на велосипеде, не пользуюсь общественным транспортом и отказываюсь от личного автомобиля.
Viskan prygikaste.
Ympäristön roskaantuminen on kasvava ongelma kaikkialla maailmassa. Myös Itämeri ja sen itäisin osa, Suomenlahti, kärsii roskaantumisesta. Suurin osa meressä olevasta roskasta roskaantuminen on kasvava ongelma kaikkialla maailmassa. Kulkeutuu mereen jokien mukana myös kauempaa sisämaasta. Suurin osa meressä olevasta roskasta on muovia. Muovijätettä päätyy mereen maalta, esimerkiksi rakentamisesta ja tahallisesta roskaamisesta, mutta myös mereltä, kuten kalastuksesta ja meriliikenteestä. Suurimmat roskien lähteet vaihtelevat alueittain.
Источников, конечно же, много, их идентифицировать сложно, но все равно это все виды человеческой деятельности. Это, конечно же, свалки, нелегальные свалки, с которых может поступать мусор, может вымываться, например, дождями или какими-то атмосферными явлениями. Сточные воды, где нет таких продвинутых очистных сооружений. Также это, конечно, сами туристы, которые приезжают на пляж и оставляют, например, сигаретные окурки.
Muovi on hyvin kestävä materiaali, jonka hajoaminen luonnossa on hidasta. Merestä löytyykin yhä roskia, jotka on heitetty sinne vuosikymmeniä sitten. Ajan saatossa isompi muoviroska hapertuu ja murustuu pieniksi mikromuoveiksi, eli alle 5 mm kokoisiksi muovihippusiksi. Lisäksi mikromuoveja vapautuu esimerkiksi keinokuituvaatteista, kosmetiikasta ja tieliikenteestä.
А есть так называемый настоящий микропластик, все, что менее 1 миллиметра. С этим микропластиком все гораздо сложнее, его сложнее найти в водной среде, да, в почве. Для того, чтобы его там найти, нужно специализированное оборудование, серьезные лабораторные процедуры обработки проб и их анализа. Именно вот эти частицы менее 1 миллиметра уже микронного диапазона, то есть там 500, 100 и меньше микрон, вот именно они представляют опасность для живого организма, и именно их изучение направлено на основные исследования в мире.
Suomenlahden rantavaltioiden, eli Suomen, Viron ja Venäjän tutkijat selvittävät mikromuovin runsautta keräämällä näytteitä meren eri osista. Tutkimus vaatii kansainvälistä yhteistyötä biologien, kemistien, fyysikoiden ja monien muiden eri alojen osaajien kanssa.
Mikromuovit ja merten roskaantuminen on aika uusi ongelma ja me ei ole tiedetty, että mikä tilanne meillä meressä on. Ja vaan seurannoilla me voidaan nähdä, että mistä me löydetään eniten mikromuoveja ja kuinka se tilanne meressä muuttuu.
Roskaantumisen seurantaa on tärkeää tehdä säännöllisesti ja pitkäaikaisesti, jotta erotetaan, onko roskaantumista vähentävillä toimenpiteillä vaikutusta meren tilaan. Kartoituksissa on myös selvinnyt, että mikromuovit ovat runsaimmillaan rannikoilla, mikä kertoo maalta tulevasta kuormituksesta.
No meidän seurannoilla ja kenttänäytteenotoilla on saatu selville, että mikromuoveja löytyy meren pintakerroksesta ja tuolta eri vesipetsaanosista. Mikromuoveja on myös tuolla merenpohjasedimentissä ja myös hyvin monenlaisissa eliöissä. Että oikeastaan kaikissa näytteissä, mitä me ollaan otettu, niin on löytynyt mikromuoveja muun muassa simpukoista ja kaloista.
Kaikki kerätyt näytteet vaativat pitkän käsittelyn laboratoriossa. Kun mikromuovit on saatu eristettyä näytteistä, niiden kokoa ja materiaalia voidaan tutkia tarkemmin mikroskoopilla. Vaikka suurikokoisten roskien haitat eläimille tunnetaan jo melko hyvin, on tietämys mikromuovien vaikutuksista vielä puutteellista.
Väga tähtis uurida, miks mikroplast on ohtlik loomadele ja elusorganismidele. See on kahjulik sellegipoolest, et sisaldab lisandeid ja absorbeerib kemikaale enda pindadele veest. Ta võib absorbeerida raskmetalle, kahjulikke orgaanilisi aineid ja nagu pestitsiidid ja herbitsiidid näiteks. Need lisandid mõjutavad loomade hormonaalset süsteemi ja tervist tervikuna.
Suomenlahden molemmin puolin tehdyissä kartoituksissa on saatu samansuuntaisia tuloksia eläinten sisältämistä mikromuoveista.
Leidsime, et põhjalähedased kalad nagu lestad sisaldavad rohkem mikroplasti võrreldes pelaagiliste kaladega, sellistega nagu kilu ja räim. Ja iga 5. põhjalähedane kala sisaldas mikroplasti, iga 15. pelaagiline kala ka sisaldas mikroplasti. Me jätkame need uuringud edasi teistes projektides, kuna see teema on väga aktuaalne ja väga tähtis.
Jotta meriroska-ongelmaan voidaan vaikuttaa, tarvitaan tutkimustietoa. Sekä tutkijoiden että kansalaisten keräämää ja tuottamaa tietoa käytetään apuna, kun etsitään keinoja roskaantumisen vähentämiseen. Esimerkiksi tietoa rantojen roskista on onnistuneesti käytetty ei ainoastaan Suomenlahden.
Okay, thank you very much. We'll get underway and try to keep on time. So I'm going to be chairing this rubbish session. A session about rubbish. And obviously this is a topic that's very much in everybody's minds, and it's great to see a number of presentations on this topic today, and also a number of posters on this topic as well. So the first speaker is Pinja Naki, who's talking online. So if we can get Pinja on the system.
Hello.
Hello.
I hope you can hear me.
Yes, we can hear you, and I'm sure the technicians will sort out everything else. So thank you very much. I'll let you introduce your topic.
Thanks. So my talk will be the fate and effects of small plastic debris in the Northern Baltic Sea seafloor. And I hope now when I change the slides, they will actually change. Did something happen? Yes, great. Perfect. Everything is good. Okay, yeah, thanks. So as we all know, the marine litter is a serious threat to the coastal and marine environment. And most of the marine litter is plastic, and currently it has been estimated that millions of tons of plastic waste has been estimated to enter the ocean every year. In the environment, the plastics slowly weather and fragment into smaller microplastic particles. And these microplastics are shown to both absorb and release harmful contaminants. And as they can be ingested by even the smallest animals in the beginning of the food chain, the bioaccumulation and biomagnification of microplastics and associated chemicals in the food chain are creating a lot of concern. I think I'm experiencing some difficulties with the slides. Okay, well, it has been proposed that seafloors would act as the ultimate sinks for most marine plastics. And when microplastics sink to the seafloor, they get in contact with the benthic fauna. And here you can see the most common benthic invertebrates in the Northern Baltic Sea, the Baltic clam, the Marencelleria polychaete, and then the amphipod Monoporeia affinis. And bioturbation is the process where when these animals transport particles and solutes in the sediment-water interface. And they also transport microplastic particles. And this was one of the things that I studied in my PhD thesis. And this whole presentation is about my PhD thesis, which consists of 4 different studies. In the first study, I studied whether the role or what is the role of bioturbation in transporting microplastics upwards and downwards in the sediment. The second part of the PhD thesis was studying the sorption of polycyclic aromatic hydrocarbons and the development of bacterial communities on different types of plastics. And the fourth part of the thesis was studying the impacts of tire rubber particles on the Baltic clam. And next, I will go into more detail of these studies. So in the first study, now I think there is, okay, thank you. Some problems with the slides, I'm sorry. So in the first study, I used microplastics made from fishing line to study whether the plastics that are deposited to the sediment surface are buried by benthic animals. And this experiment lasted for 3 weeks and was conducted in these types of experimental cylinders. And half of these cylinders contained a community of the previously mentioned invertebrates in natural densities, and half of the cylinders were without any animals and acted as controls. After the experiment, the sediment column was sliced and microplastics were extracted and counted from each layer. Then moving on to the second study, which also was about bioturbation. This was similar to the first one, but this time we wanted to know whether animals could transport buried plastics back to the sediment surface. The plastics were made from Lego bricks and they were placed in 2 layers in the sediment column. The uppermost layer was in 2 centimeters deep and the deeper layer in 5 centimeters deep. And again, half of the cylinders contained animals and half did not. And this time the experiment lasted 10 weeks. Then into the results. Thank you. So the results of these studies show that 8% of the microplastics residing in the sediment surface were buried deeper in the sediment. And the effect of animals on the microplastic burial extended to approximately 5 centimeters deep, which corresponds to the estimations of bioturbation depth in the Baltic Sea. However, from the microplastics that were placed deeper in the sediment, only around 1% were returned to the sediment surface by the animal activities. These studies together broadly suggest that the Baltic Sea sediments could act as microplastic sinks as the net transfer of particles were downwards towards the deeper layers in the sediments. So when the microplastics are buried, they tend to stay in the sediments. In both of these studies, we also studied whether the animals are ingesting the microplastics. In both experiments, the Baltic clam was the only species that ingested microplastics, and probably because the used plastic particles were too large for the 2 other species. In the first study, where the microplastics were placed on the top of the sediment, on the sediment surface, 25% of the clams ingested microplastics, whereas in the second study, where the plastic particles were placed deeper in the sediments, only 1% of the Baltic clams ingested them. This pattern is probably explained by the fact that these animals feed from the sediment surface, as you can see from the GIF in the side. And that means that they are probably most exposed to the particles when the particles are located on the sediment surface. And the risk for the ingestion decreases when the particles get buried. Then on to the third study. Can you put one slide backwards, please? Thank you. So not only microplastics, but also various anthropogenic contaminants accumulate in the seafloor sediments. And in this third study, we focused on the polycyclic aromatic hydrocarbons that are present in the sediments. And we wanted to examine how they are sorbed to different plastic types. In addition, we wanted to examine the potential degradation of the selected plastic types by studying the bacterial community composition on these plastics. And in this study, we compared conventional and biodegradable plastics as the use of biodegradable plastic materials are constantly increasing in the society, but we don't really have information on their true biodegradability. And now these results, I first tell you what we did. So we had 2 conventional and biodegradable plastic types, and they were cut into different shaped pieces, but they had the same surface area. These particles were incubated in sediment and water that were collected from 2 sites located in coastal Helsinki, and the incubations lasted 14 weeks. Half of the plastics were used for studying the PAH concentration, and half were used for bacterial community analysis. And what we found was that the bacterial community composition on the biodegradable cellulose acetate was distinct from the other plastic types. The bacterial community on this material also contained bacteria that are capable of degrading complex carbon substrates, including cellulose. It's possible that the enrichment of these bacteria is because of their capability to degrade cellulose, but we did not actually see any visible signs of degradation. And when we look at the PAH sorption to the different plastic types, we found that all plastic types sorbed PAHs from the sediments, but in all cases, the conventional polystyrene was the material that had the highest concentrations. The differences in these sorption patterns indicate that some plastics may be more efficient vectors for harmful contaminants. But when we examined the concentrations of PAHs sorbed to plastics, they were clearly lower than the PAH concentrations measured in the sediments. And from here, we could see that the importance of microplastics as PAH vectors to sediment-dwelling invertebrates seem to be low, as the animals are more exposed to the PAHs in the sediment than they are for the PAHs in plastics. Then the final and the fourth study. And here we wanted to study whether the exposure to tire rubber fragments have any negative effects on the Baltic clam, because we know that some ingredients of the tire rubber can be really harmful to animals. So the background of this study is that there was a report published last year in Finland that identified car tires and artificial turfs containing rubber granulates as one of the largest microplastic emission sources in the whole country. And the tire material indeed consists of a mixture of different kind of synthetic and natural rubber polymers, as well as numerous additives. And many of these additives can be harmful, such as metals and PAHs and phenolic compounds. And that's why we wanted to study if they have any effects on the Baltic clam. And we focused on studying biomarkers, and we selected biomarkers that are the key enzymes in the antioxidant defense system of these animals. And the antioxidant defense system consists of many enzymes that together try to compensate the harmful effects of contaminants and the contaminant exposure. And eventually this can lead to the protection of the cells, or if the protection is somehow incomplete, this might cause oxidative stress and oxidative damage as well. And in addition, we also studied the changes in the cell ultrastructure, for example, changes in the cell organelles. So next, I will show how the study was made. So there were 3 types of aquaria. In the next slide, please. Thank you. So we had 3 types of aquaria, and one of them acted as control. One had rubber powder inside a mesh bag, and one had rubber powder freely in the aquarium. And the idea of this setup was to compare the potential effects in the clams in cases where they could ingest the particles, and in the cases where they could not have any contact to the particles, and they would also only be exposed to their leachates. And the study was divided into 2 experiments. The acute experiment lasted for 5 days, and the chronic exposure lasted 29 days. And during both of these experiments, the metals and PAHs from the water were measured, and at the end of the experiment, the clams were taken out and dissected. And now I will show the, can you put the previous slide, please? The results. So as you can see from the GIF, the clams ingested these tire rubber particles. So there you can see a siphon of one clam, and all the black small particles are the tire rubber particles. And multiple metals and PAHs were also quantified from the experimental water, especially in the particle treatments. When we looked at the biochemical biomarkers, some of them did not show any differences between treatments, but in some, the clams exposed to the particles showed elevated stress responses, as can be seen here in this figure of the superoxide dismutase enzyme, where the chronic particle treatment clams had the lowest SOD activities. Then we also found that the chronic leachate and particle exposure induced changes in the cell nuclei and other organelles, indicating that the antioxidant defense system has been overloaded and oxidative damage to the cell structures had occurred. For example, in these photos, these 3 photos, we found that there are disruptions in the mitochondria, which are marked with stars, and some disruptions also in lysosomes that are marked with the letter L, and also found some problems in the gills of the rubber exposed clams. And finally, to summarize in the next slide, the bioturbation was shown to play an important role in the vertical distribution of microplastics in the sediments. And the common benthic fauna in the northern Baltic Sea seemed to facilitate the burial of microplastics, while at the same time reducing the bioavailability of microplastics and promoting their preservation in the sea floor. And since the redistribution of buried microplastics back to the sediment surface was quite small, the results also suggest that the Baltic Sea sediments act as microplastic sinks. We also showed that when the plastics end up to the sediments, the polymer type can influence their fate and risks that they pose to the benthic habitat. For example, the bacterial communities that were found on the biodegradable cellulose acetate was different to the other plastic types and had potentially biodegrading bacteria. But we need further research to verify whether the biodegradation of these materials could really be possible. And also the varying PAH sorption capacities on different plastics indicate that if ingested, their roles as PAH vectors can also depend on the polymer type. But however, compared to the sediment concentrations, we also showed that probably the PAH sorption to plastics is not going to add the PAH burden of deposit feeding animals. And finally, sorry.
Thank you.
Just final remarks that the tire rubber particles were also ingested and caused some elevated stress responses. And if you are interested to hear more, I have included a code to download the PhD thesis from the last slide. Thank you.
Thank you. Okay, thank you, Pinja. We don't have time for questions. We'll move straight on to our next presentation, which I think is in person. Alexandra Urshova. Thanks, Alexandra. I'll leave you to introduce your topic. Ooh. I might sit over this side. Thanks, Kai.
Okay, good day. Dear colleagues, it's a pleasure to meet you here face to face. And on behalf of our group of my colleagues, we will present today I actually constructed our presentation in the form of review of what we've done so far for these 2 years that we haven't met with you. So that's why it won't be so focused, but it will be rather an overview of what monitoring activities and what results we obtained from the Russian part of the Gulf of Finland during the last years. So our university, Russian State Hydrometeorological University, we started this to work on marine litter microplastics in 2017, and since then we've got some results. First of all, we started with monitoring of the coasts of the aquatic environment of the Neva Bay, but we actually even moved further. During these 2 years, we now also having another part of our research, very major part of our research work is connected to the Russian Arctic and the Far Eastern Seas. So all of the methods, especially what comes to the microplastics research in the water and seawater, now we are adapting these methodologies and searching for microplastics in the Russian Arctic. During these years, we have organized a specialized laboratory on plastic pollution research, where the major, I would say, workforce is the young scientists and students. So I'm the leader of this laboratory, but of course, all this work that I will present today, most of this work wouldn't be possible without the so many volunteers and students that have been working and are working in our university in this lab. Yes, during this time we worked on the development of observation techniques. We are developing and adapting some laboratory analysis and of the international experience to our conditions of the brackish waters, of the eutrophied waters, of the freezing waters. So there are many limiting factors, and we made new sampling devices, and also we worked on the intercollaboration of methods with our colleagues, not only from Suke, and this work will be presented later by our Finnish colleagues, but also we're working closely with the Russian institutes. Because of the pandemic, we cannot really collaborate. It's really limiting our collaboration efforts abroad. But we took advantage of this, maybe I would say, and we worked closely these years and are working with national scientific institutions. So we're focusing on two fractions. I must say that you have to distinguish, because we are monitoring the large microplastics, which is larger than 1 millimeter, which is visually detectable. This is the microplastics in the sand, in the beach sand. And also we're working with microplastics in the water, which is the real, I must say, the true microplastics, which is only detectable by the special instruments. As I said, we started with the Neva estuary, started our studies with beach sand samplings to identify the hotspots of its accumulation, so of plastics of litter accumulation in the Neva Bay, and also to make a database and to define the basis for the mathematical modeling of the distribution of microparticles in the Gulf of Finland. And the methodologies that we used, these are, first of all, the two methods for sandy coasts, for sandy beaches. Then we also worked on the water sampling and made our own filtering device, which is patented now. This is working with it, and its construction and the model and the recently it was patented. And also we working with the samplers for the vessels. Also developed the method for working in a flow-through system in the vessel. Our also major part of our work was on analyzing and trying different methods, laboratory methods, and during this time we not only, of course, used the microscopy methods, but we worked with Raman and also with the pyrolysis gas chromatography and mass spectrometer methods. And so beach litter monitoring, it was based on these two methods for large microplastics. And you can see here the various pictures of how it looks in summer in the Neva Bay. And the top litter items in the Neva Bay are here, and you can see that they're quite diverse, but as you can see further, they in a way differ from other parts of the Baltic. Sorry. So these are pellets, one of those top litter items, the primary microplastics that is made for producing some goods afterwards, like bags of some other things. A lot of synthetic napkins, etc., and also the cotton swabs that people use somehow flush down the toilet, and they shouldn't do that, of course. And when it comes to The Baltic, this is the paper that we, our colleagues on behalf of our research groups just submitted. You can see that the yellow is artificial polymers, so mostly at least half of the litter on the beaches of the Baltic is composed of artificial polymers. And red is cigarette butts. So you can see here how many people do smoke on the beaches in the Baltic. And of course, there are beaches where there are more smokers and where almost no smokers. So not much in the Neva Bay, but mostly cigarette butts in Lithuanian and Polish coast and German as well. But when it comes to the Neva Bay, what a major result that we found that most of the accumulation of the microliter happens in the Neva Bay itself, so the dam doesn't really allow it to move, for microplastics to move further. We did some modeling experiments that also showed the distribution of microparticles in the bay, and also, when it comes to measurements in the water, microplastics in the water, we also see that there is a trend that most of the plastics, microparticles in the water, they tend to accumulate in the near the northern coast of the Neva Bay. But when we compare different years, there are some things that have to be taken into account, and we can say that there is a need for much further studies, for further research. They need to be much once a year is not enough to make the samplings. The measuring unit is also very important to take into account, because you can see here there is on the right graph that if you take the weight and if you take the amounts, so in pieces, you get a totally different result sometimes, because the plastic is much lighter than metal, etc., and the glass. So you have to combine the units, and it's very important to when you do the monitoring. Well, yes. Also, when we compared the water and the sand, got some interesting, well, I would say, trend as well. That again, our theory of accumulation in the northern part of the Neva Bay is confirmed. And what about the harmonization of methods? This is a very important question that we would like to stress, because this work in the Neva Bay was also carried out by our colleagues from the Institute of Limnology that are presenting their work on the poster. And on the left is our measurements in the water and in the sand done in parallel last year. We did it in one day, just specially so that the conditions would be the same, and we got more or less consistent picture. But when it comes to comparison of different institutions, so we did the same microplastic sampling in water with more or less the same method, but in different time, you see that they totally differ, and that doesn't mean that one of the methods is wrong. It's just a very dynamic picture of dynamic character of distribution of microplastics. So if you want to read further about our research, we've published some of the papers during this time, and one is to come. Also, we developed a study course, which is also a very good outcome of this project that we finalized this year, that we developed a study course in Russian. It's now introduced in the curriculum of our university, and the textbook is now in its finishing step of publication. And also, yes, here the students, you see that all the photos, they contain, pictures of students, of course, those who actually made this work happen during these years. And some conclusions and recommendations. First of all, of course, the methodological approaches must be harmonized, not in just one institution, but between the institutions, because there are so many limitations, and the character of the distribution of microplastics in water especially is so dynamic. We, however, managed to see the hotspots of accumulation of microplastics in the Neva Bay in the Gulf of Finland, and now our database comprises over 1,400 units of measurements for these years. There is a lot of questions about the sources of this microplastics, because this could be treatment facilities and some untreated wastewaters and other sources. This is something more to study and to find out. Also, there is not much information about the tributaries, about the Neva River itself, so in the entire water column, so more research to come. And of course, in order to develop the scientifically based measures for the management of the sources and for the recommendations for the decision makers, it's necessary to have this entire monitoring based on the unified methodological approach. This is actually the main idea of our intercollaboration efforts that we are having now with our Estonian and Finnish colleagues. And of course, we have to work with the society, because as you can see, the most of the plastic comes from the household, from the hygienic products. And our proposals because our forum today is called the New Start for New Cooperation. Hopefully, it will really start in this topic too. I mean, it's already happening, but the new cycle of it, yes. So the efforts should be focused on harmonization of the sampling methods, because there are so many different methods and different research teams, research groups use various sampling methods. The same goes for lab analysis. Must be unification. So the joint intercollaboration of monitoring methods should be done not only for water sampling, which is now actually almost completed for our teams, but also for the beach monitoring, which is not. I mean, it's the question for the future, I think. Also, regarding the modeling of microplastics in the water, we think and we propose that we have to study the microplastic properties changes under the influence of biogeochemical processes based on the eco-hydrodynamic models. And also the educational courses and programs and maybe field trainings, etc., could be also the topic for cooperation, because a lot of young scientists and students are volunteering for this work, and they are really happy to take part in this work and to work because they want to change the situation. Thank you. I think this is it.
Thank you very much, Alexandra. We are going to have to just move on at this time, but thank you very much. The next talk by Tia Mola-Reid, I think, is in person, maybe not. Does anybody? Oh. Yeah, okay, thank you. Sorry, I didn't see you.
No, it's okay, thank you.
Thank you very much. I'll leave you to introduce your topic.
Yes, just a second. Hello, I am Tia, and I will talk a little bit about our True Curiosity project, which will focus on marine litter in the small islands of Estonia. And just to say again that marine litter is one of very, very many pressures that people are putting in our marine environment. And if you talk about this marine litter, then it is defined as any persistent, manufactured or processed solid material that is discarded, disposed, or abandoned in the marine and coastal environment. So we can find it nowadays every place, in the surface, in water column, in the floor, in biota, and on the beaches. And as already said before, it is in all sort of sizes. And when we talk about marine litter pollution, then of course the main focus is on plastic pollution. And globally, actually, the Baltic Sea region, it is in a quite good situation. Most of the plastic waste is coming from the Asian areas. And in the Baltic Sea region, it's actually quite good. We have proper waste management. We have not so much population in our coastal areas, so it should be quite okay. But anyway, the population is growing, and the need for plastic and also different sorts of materials is growing. So we're just curious. We know that a lot of nice areas have become trash islands, that marine litter just travels from the sources very, very far. And knowing what's going on globally, we just wanted to know what is going on in our Estonian small islands, which are not inhabited by people. So, in total, in Estonia, we have over 2,000 islands. So we had to make some kind of choice. And we made it so that our criteria were as follows. We had the minimal area for the islands, half a square kilometer. Then we wanted to have this grass and bushes present, so it wouldn't be only rock island. And we wanted to have the islands to represent different regions of Estonian coastal sea. And so we had 3 in the Gulf of Finland, and also in Väinameri area, in the Gulf of Riga, and also in these open areas which are open to the Baltic proper. And also it was very important that islands would lack human settlement. For the Gulf of Finland area, I marked these islands, that they are located, one is in the entrance of the Gulf of Finland, Suur-Pakri Island, one is in the middle, Suur-Malusi, and the most easternmost was Uhtju Island. So, our methodology was a little bit restricted. We couldn't go there as much as we wanted to, because they are like all these areas are about 10 kilometers away from the coast. And we also had a short project time. It was from March 2019 to December 2020. So our fieldwork was actually carried out in June 2019 to October 2020. And for most of the islands, the movement was prohibited during bird breeding period. So we started off with 12 islands, but we ended up with 13 islands that we visited 4 times, and one more island that we just visited 1 time out of curiosity once again. And when we already went to these far and the remote areas, then we wanted to get as much information about litter as possible. So we actually looked into the water area, we looked for the beaches, and we also looked for vegetation, because with water level raises and storms and winds, this litter is usually carried towards the inland. So yeah, we just made our regular beach litter, we took this regular beach litter survey area, and we made it wider towards the sea and the vegetation. And we tried to collect information on macro litter, a bit of micro litter, and we also observed what are the effects for biota. So our beaches, we didn't focus on sandy beaches, because in an Estonian coastal area, also these moraine cliffs can be accumulation areas for litter. It's not only sandy areas. And as it turned out, the litter gets stuck between these stones very well, and then it is washed out from there, etc., etc. So it was actually a bit very, very interesting, especially for Suur-Pakri Island. So yeah, our beaches looked very different, and also our vegetated areas looked very, very different. And also these uniparous communities, they are very, very good collectors of all kind of litter. So, about the results, actually there were not too much surprises that most of the litter that we found was really indeed plastic. And but it was surprising that we didn't expect that much litter, to be honest. In total, we described over 12,000 litter items. And we removed about most of them, well, and in total weight, 854 kilograms. That means that they were mostly, these were light objects, but there were also some very, very heavy, and these put more weight to total weightness. And the different materials were present both in the beach and vegetation, and this was only a bit different for organic waste. That was that we found mostly on the beach, and not so much from vegetation, which is rather logical also that it just disappears from the beaches. And if you look at the litter material composition in studying the islands, then there were some varieties, and especially for Arilaid and Pihlalaid, and that is actually there was before some buildings on these islands, so that's a bit shifted. But for others, mostly it is that plastic litter forms 60 to 70% of all the litter items, and that seems to be quite a rule. And if you look island-based, then most of the litter items we found in Uhtju Island, which is located in the Gulf of Finland, in Suur-Pakri Island, which is also located in the Gulf of Finland, and Suur-Malotsi and Salavamaa Islands. And but now if you look at the litter weight, then it was most came from Suur-Pakri Island. And this Suur-Pakri Island, it's just on the entrance, and it's a large area, and it's a stony area. And I think we really went to the this zone where nobody had been before, and we were just two of us, and we went there and we stayed there for 6 hours, and all we could do was collecting the litter. And it was awful. For the first time, it was really like, is it going to be like this for every place? So it was awful. But luckily, it was not so worst for all the places. But it was that these Gulf of Finland areas and the islands that are open to the Baltic proper, they get more from the sea. If you walk, now if you talk about the main litter items and the best travelers, then plastic bags, plastic food containers, plastic pieces and plastic bottles formed about 50% of all found litter. About cigarette butts, which are a huge problem in our urban areas. Altogether, we found 25 from our visited islands. And in some cases, we could say that they come from boats or nearby harbors, or they could also be left there by some visitors. What was also interesting was the quite big number of balloons, both rubber and plastic balloons, and shoes and boots also. And also what is glass bottles and glass jars, they are also quite typical. And in Suur-Pakri Island, in this Gulf of Finland area, there was this, I think we collected most of the alcoholic bottles from there, quite expensive ones actually. And all set and all in one piece, not broken. So, about spring 2020 and lockdown due to COVID-19, well, there was this question about the masks, how do they affect the biota, etc., etc. Well, within our research period, we did not find these new masks on the islands yet. Although we had masks in total 5, but these were like, I believe they are from the boats and from the harbors, and if you just paint or do something with the boats, then they can get lost. And we also found some rubber gloves, but not too much. However, since summer 2020, there was new type of litter in Uhtju and Malusi Island, and these are wet wipes. And wet wipes have been with us for almost as long as plastic items, or plastic itself. But this COVID lockdown certainly brought a new use of those as just wiping hands. And for Uhtju and Malusi, it is also important to note that probably these wet wipes were carried there by birds. So, if you talk about amount of litter per 100-meter long beach section, then there is a set threshold value of 20-liter items. That means that if there are less than 20-liter items per 100-meter beach section, then it should be in good environmental status. Well, for our beaches, we can actually say that we saw the decrease in the litter amount. We went there, we collected, and by the 4th time when we visited, Suurpakri was already in good environmental status. But it's not perfect, but at least it's something, and now we know that the load is not that massive, but it's still there. And also for the vegetation, well, there are some issues with the vegetation because it depends on the time when you go there and how much you see, etc., etc. But and thus we didn't see the decrease in the number of litter items as much as we wanted to, but still it's promising that if you clean it once, then it should be gone away. So we also checked for marine litter and biota, and well, yes, there are some signs that well, it is found in bird pellets, and it can be used also as nest material. We didn't find any animals dead because of litter directly. So here is just to show how it was used as a nest material. So I think I'm running out of time, so just to keep in mind that we also found microlitter in sediment. It was not much, but it was still there, up to 6 particles per 100 grams of sediment. And most common was, again, plastic fibers or glass pieces. And in the water area, both plastic fibers and glass and metal pieces could be found. So, to quickly sum it up, well, we don't see much of the litter floating around, but still it travels. It does travel. And for Kirjurahu, which was in Gulf of Riga area, with 2 months' time, we could found 8 more plastic puddles. So that's an average rate that we could see there. And is this, I think very many areas that we visited were nature-protected areas, and we are not allowed to go there, but litter is still there. So I don't know, but I think we should rethink about our protection rules and how to remove marine litter also from these areas. And it's an endless fight, for sure. But there might be some edible, nice surprises as well. And it might be also that eventually we'll see a pure coastline. So thank you. It was a huge work.
Thank you very much, Pia. We'll again omit questions to try and keep on track, although I've just noticed that there is a slight typo here that says this session ends at 15:15 or 15:30, so I'm not actually sure if we're running early or late, one or other. But
okay.
We'll try and keep to time. Thank you. Thanks. The next speaker is Julia Talvitie, who I believe is online. Am I correct? Yes.
Yes.
Julia, can you hear or?
Yes,
okay.
Do you hear me?
Thank you. Yes, we can hear you, and welcome, and I will leave you to present your topic. Thank you.
Thank you. So my name is Julia Talvitie, and I'm from Finnish Environment Institute, working with microplastic at the urban stormwater runoffs. It's my pleasure to be here today. So how would I describe my topic is that I look mainly for sources and pathways for microplastic to the environment, to the aquatic environment. And why it is important is that those are the places where we can actually do something about the issue, microplastic pollution. We can either try to remove the sources or remove microplastic pollution from when they are in the pathways, like in a wastewater, or in some cases in stormwaters. Today, we are focusing mainly on stormwaters, but very significant pathways are also wastewater treatments, municipal wastewater treatments, and industrial wastewaters. We know very little about the stormwaters as a pathway. It's pretty challenging environment to look for microplastics. But it is very significant place to look because although we don't exactly know, but we have a good educated guess that it's very significant pathway. Large amounts of untreated stormwaters, particularly in urban environment, discharge all kinds of dirt from urban environments to the aquatic environment. In the future, due to the urbanization, bigger cities constantly, and climate change, the role is only getting bigger. It is also a very meaningful place to watch microplastic pollution because with stormwater management, we can probably manage also microplastic pollution discharges. Maybe already we do with some stormwater management, or then we can develop some new ideas how to manage it even better. I will now shortly tell you about my study that I did in Espoo in Finland. It's the second largest city in Finland, and I studied the catchment area in urban suburb. The type of catchment area is pretty important to know because it definitely affects the quality of the stormwaters and amount of microplastics. Suburb, which around 50% of was impervious surfaces like roofs and roads. When I started the study, I had to put a lot of effort on thinking how I will sample microplastics in stormwaters. We have already some ideas how to sample stormwaters, how to study the quality of stormwater, but with microplastics, it's still a bit trickier because as other researchers before me here today mentioned, the size classes is quite wide. if there are different kinds of plastics, how I would grab all of them for my samples, or do I even try to grab all the size classes? So I started to think that I need quite large volumes, because not necessarily all stormwaters include so much microplastics, and bigger plastics are more rare, most probably. So I would need to have enough volume. What would be the sufficient sample volume? I wasn't sure. I had to check. I was starting to look from the wastewaters, where they usually used 1 cubic meter. So that was a start. Stormwater is like an event with fluctuating flow. It's not flowing like in a constant flow. So I was thinking that if I want to actually take a representative sample, I would need to take flow changes into account. And of course, I would want to have some kind of a mean concentrations, like maybe from the whole rain event, and sample enough from the one catchment area, so that I would get an idea of mean concentrations. I'm not going into details with this machine here, but I developed, with the help of my friends, this large volume, flow-based large volume sampling device. So basically, it measures with the V patch, it measures the flow constantly, and the flow meter tells it to the computer, and the computer tells it to my pump to take samples to my filters flow proportionally during the whole rain event. So the idea is that I sample the whole rain event from the start to the end flow proportionally. I will show what kind of a figure I get. So the upper picture here shows the actual rain event. It starts and then it rains like very heavily for a while, and then it calms down, but the flow is still, the stormwater is still running. And the picture down just tells how the pump mimics the actual rain event. And I know in the end how much from the whole rain event I got from my sample flow proportionally. It's not all about sampling. As mentioned in earlier presentations, samples need quite much work after sampling. We have to extract microplastics from the samples. We need to analyze it. And after the analysis, we have to also understand what the analysis tells us. And we need good quality control samples so that we can prove that we do the work with good quality, so that we don't contaminate all samples or lose the particles there. This is just a picture of showing how the stormwater sample look in the first place. It's rinsed from the filter into this glass beaker, and it's very dirty. It includes everything, sand, a lot of biological materials, and also a lot of plastic. But it goes through the digestion methods and it gets more pure. And after that, we will put it to the FTIR. And after the FTIR, we hope to also use pyrolysis method to maybe get some information from the rubber tire, but this is in the future, hopefully. My preliminary results showed pretty much what I expected. It shows that even though I sample from the same catchment area, the variation with microplastic discharges is quite huge. So it depends, of course, dry period before the rain, how dirty are the roads. But it also depends on what kind of a rain event. Is it very harsh rain lasting for a long time, or is it just a short, small rain? And here you can look, I put 3 different rain events here. And if you look at how much they discharge, so the most discharge comes from the, very, very large, like very heavy rain event. It's raining a lot. There's a lot of stormwater. The concentration is not necessarily so high, but the end result is that it discharges over 1 million microplastics during the rain event. But also smaller rain events can, if the concentration is high, like in the first rain event, it can be quite significant discharge of microplastics. There wasn't surprises of the most common plastics type found, like almost all studies, so polypropylene and polyethylene are the plastics that we use a lot in our society. So we see that also in storm waters. I also give some preliminary results from master's thesis of my student, former student Pietu Pankkonen. And this is just to show that stormwaters are a quite nice place to look at the microplastic pollution, because it hints that we can do something about it. Like I mentioned, we already manage stormwaters in many ways. And this was one type of way of managing stormwaters and improving the quality. This kind of a filtration system was developed for removing microplastics, but also improving the quality of the stormwater in general. This filtration system is targeted to like city centers where there is not a lot of space. So this filtration system can be like a sun deck on a shore, or it can be a fence, or it can be many other item or activity as well. But inside of it, there's a filtration system, and 2 different filter material were studied, sand and biochar. And if you don't remember anything else from this picture, you can look that before this filtration system, there's a lot of microplastics per liter. So it's quite dirty urban stormwater. It has a huge variation, from 8 to 66, again, depending on dry periods before taking the samples, depending on the rain event, how long and harsh it is. But no matter what how the rain event was, it significantly removed microplastics from stormwater. This was installed next to road, very high traffic road, and the idea was that this would also stop from microplastics from traffic to ending up in the Gulf of Finland. A lot of people have contributed this study so far, and I want to say thank you for all of those. Thank you.
And thank you for keeping well within time. We actually do have time for questions of Julia. Has anybody got anything they would like to ask? Tarmo. Oh, sorry, I don't know how this works.
You showed that some simple filters like sand are very effective in removing microplastics. How long this capacity is persisting?
This was quite pilot scale, but it is very significant. It's a very good question. It's very significant that it doesn't need constant purification or maintenance, because these would be quite expensive to maintain. I don't know exactly, but not like often, maybe years working and without the maintenance. But definitely, I think this type of a filter is applicable in places where there is like high levels of microplastic pollution or high levels of other pollution. So I wouldn't put this like next to a forest or fields, but maybe in city center, this can be like targeted to like this kind of a hotspots areas.
Thank you. Are there any further questions? Okay, thank you very much. Thanks very much, Julia. The next speaker, Maria Peldma. You're hooked up, yes. Thank you very much.
Hello, my name is Maria Põldmaa. I'm from Estonian Marine Institute. And for a few years now, I have been involved with some projects dealing with marine litter. And one of those projects was conducted in 1920, which was about ingested litter in marine animals in Estonian coastal waters. And where we developed the methods and assessment for Marine Strategy Framework Directive. This is was one of the first extensive studies about ingested litter in Estonian coastal waters. And as we all know, marine litter is a global environmental problem in which one of the major concerns is ingested litter by marine organisms. And the management of marine litter in Baltic Sea is organized within the framework of Marine Framework Strategy Directive. And there's one decision that requires that the amount of litter and microlitter in it ingested by marine animals is at a level that does not negatively affect the species. And at the moment, these harm levels are not known, so it's difficult to set some direct level that we should all okay. And until those harm levels are not known, we have to assess the trends in the amount and composition of ingested litter in marine biota. And we need some kind of baseline quantities for that to give such assessments. And the main objectives of the current study is to compile a basic data about microlitter ingested by different organisms, and to develop methods for that, and to select indicator species for future assessments. And most of all, to get the baseline values for future assessments. This is what the current study was aimed to do. Shortly about the microlitter in general. When we talk about microlitter, we mean particles which are smaller than 5 millimeters. These could be a range of different materials, as different polymers, rubber, textiles, processed wood, metal glass, or paint particles. And these 5 millimeter particles are just about the size that organisms could mistake it for food or ingest it unintentionally. It is also shown that microplastics can provide a pathway facilitating the transport of harmful chemicals to marine organisms, causing chemical toxicity. The studied species in the current project included many demersal fish species like perch, pike perch, flounder, round goby, bream, turbot, eelboat, cod, and smelt. And the pelagic species we analyzed were Baltic herring and sprat. Bivalves analyzed in this study were blue mussel, lagoon cockle, Baltic macoma, and sand caper. And we also included crustaceans, Harris mud crab, and Saduria entomon. And the samples were collected over the coastal sea of Estonia, including Gulf of Finland, western side of Estonia, and Gulf of Riga. Shortly about the methods, I won't go through that in detail, but as you see, there are many steps analyzing microrhiza in organisms, and in every step of this process, we can contaminate the samples ourselves, or the contamination can come from the lab or even from your own clothes that you wear at the time. So it is crucial to use blank control, to avoid or to reduce such contamination. And there are also several other procedures. And I put here some filters that we analyzed. That on top of them, there you see the filters of bivalves, where all the organic matter was nicely dissolved. And these are quite easy to analyze and detect the microrhiza particles. And at the bottom one, you see the one from round goby, who was eaten quite well, and the shells of the bivalves don't dissolve in the potassium hydroxide, and these filters were much more complicated to analyze. In case of crustaceans, we opened the carapace directly under the microscope and extracted the intestines, and then visually examined the intestines under the microscope. In case of, in every individual, we determined the abundance of microrhiza items in the organism. We measured the length and diameter of the particles, and also determined the color of the particle, and also determined the material and shape of the particle, whether it was straight and easily measured or in clump, etc. And we also divided those particles into 3 different size classes. And to distinguish between plastic and organic material, we used a hot needle test, which is quite simple. I put one photograph of it on top of there, where you see the piece of plastic film, the green one, when it was elongated, and after I touched it with a hot needle, it crunched together. Okay, so now about the results. Here you see the graph about the distribution of microrhiza in different fish species. If we pool all the results together for fish, then about 30% of them were found to be contained microrhiza. And in case of perch, turbot, sprat, and smelt, we got the highest percentages, over 40% contained microrhiza of them. but it's important to mention here that there was a quite big variation in number of analyzed individuals. We managed to get only 10 individuals of turbot, but we had many perch. And there was no difference between demersal or pelagic species, so the 40% was in both of them. It was surprising that such demersal fish like flounder contained only 20% of them contained microrater. Mainly, we found 1 litter item per one organism. Occasionally, there were 2 to 4 items. Here is the graph in case of fish that we could collect in 3 different areas. These were perch, flounder, round goby, and herring. And the highest numbers we got that were contaminated, we got for Gulf of Riga and in case of perch. Followed by Western Estonia, and which was also surprising that in Gulf of Finland fish were less contaminated than in other areas. In Gulf of Riga, we also could compare 2 methods, what was used to collect fish. This was gill nets and troll nets, and we found that the fish collected with troll nets were contaminated 10% more than the ones collected with gill nets. And we found also significant difference among ingested litter, number of ingested litter among Gulf of Finland and Gulf of Riga. And if you look at microrater categories in fish, we see that almost 80% detected particles were fibers. We see the gray area. And around half of them were in blue color. All demersal fish also in them were found plastic fragments, but not in pelagic fish. And this was also the case with paint and glass particles. Pelagic fish didn't consume them. And when we see the results of macrozoobenthik organisms, we see the similar number, 30% were contaminated. We didn't see any difference between marine areas or species, which was significant, and 70% of them was found 1 particle per individual, and around 20% consist of 2 particles. And if we look 2 areas where the bivalves were collected, Gulf of Finland and Western Estonia, we see that contamination in species was quite similar. In case of Mya arenaria, sandcaper, we saw the biggest differences. And as like the fish, mainly the categories of materials were fibers, and of which 90% were plastic fibers. And around 60% were blue, and around 16% were red. And 10% of fibers found in Harris mud crab were clumped together. Interestingly, the longest was 19 millimeters. And the other categories, non-fiber categories, were relatively evenly split in bivalves. And if we look at the size classes of the particles we found, mainly they were larger size class in 1 or 2. Some particles were bigger in size than microliter, so they were determined as mesoliter. And smallest items mainly were only in 15%. So there was no big difference related to feeding type. Mainly larger items were both in bivalves and in fish. So if we choose the indicator species for the future assessments, there are some criteria these selections should be based on. They should be representative for specific environmental compartments and different feeding types, for example, have a wide distribution, and for comparisons with other areas, have a commercial value, if possible, and they should be already described as a regular litter consumers by different studies. Which assessed demersal fish for indicator species to be perch and flounder, and pelagic species, Baltic herring and sprat. From macrozoobentic organisms, two more abundant mussel species would be good indicators, like blue musser and Baltic macoma. And also we would select Harris mud crab. To conclude, we suggest sampling from different areas for ingested litter assessments, and at least 30 individuals from one species and from one station should be analyzed. And if we now know the base values of an amount and composition of microliter, we can now assess either the situation is getting better or worse or stays the same. Thank you from me.
Thank you, Maria. Question? Anybody? Okay, one question here.
Sorry, what can I speak about Saduria, microplastic?
Saduria?
Disease. Saduria.
Yes, I go back there. Oh yeah, I forgot the graph of Saduria. In case of Saduria, we only had 10 individuals, in which 3 of them contained microliter. And these were all plastic fragments, so small fragments.
Thank you.
Okay.
Okay. Anyone else? Quick question? Okay, thank you. Well, as I said before, we're either running early or late, depending on which version of the timetable we look at, but I'm sure with the extra 5 minutes, people can track down the speakers and ask questions, or there are, I know, many posters outside on a similar topic, which I'm sure would be interesting. Just a reminder for the next speakers in the next session, during the break, to visit the room at the back to get your microphone fitted, and I'm not sure if there are any other announcements before we take a break. Okay, break time, and I presume it's back here at 15:45. Yep. Thank you very much.
Thank you.
Thanks, Maria.
So, good evening again, ladies and gentlemen. We are starting the session 3, Ecosystem Studies. And the first 3 presentations will be online. So the first one from Finnish Environmental Institute, Katri Kuupo. Please, can you hear us? The floor is yours.
Yes, I can hear you. Okay, thank you. Good afternoon. My name is Katri Kuupo and I work as the consortium manager of Finnmari Marine Research Infrastructure. And now I'm going to present you briefly what Finnmari is about. But first to the basics. So what are eventually the research infrastructures? So they are for sharing resources and knowledge. And according to the EU definition, research infrastructures are facilities that provide resources and services for research communities. They foster innovation and produce data that can be used by the society at large. The facilities can, for example, be instruments, sets of instruments. They can be laboratories, computing systems, and networks, data, collections, and so on. In the European research area, the ERIs are an important element in the scientific excellence pillar. Also on the national scale, the Academy of Finland coordinates the roadmap of research infrastructures in Finland. Finnmari has been on that roadmap since 2014. You can see in the slide the list of the current national RIs after roadmap update in 2020. And out of about 3 or 4 environmental RIs, Finnmari is one of them. So Finnmari is a multidisciplinary and multi-platform research infrastructure. And it focuses on societally relevant pressures to the ecosystem on the Baltic Sea, the climate change, eutrophication, overfishing and habitat disturbances, as well as ecosystem services. And Finnmari supports and facilitates the research and observations in marine physics, geology, and biota, as well as biodiversity and ecosystem functions. Partners in the Finnmari consortium are 3 universities through their field stations, Tvärminen Zoological Station of the University of Helsinki, Archipelago Research Institute of the University of Turku, and Husö Biological Station of the Åbo Academy University. It also holds 4 governmental research institutes, the Finnish Meteorological Institute, Geological Survey of Finland, Natural Resources Institute Finland, Luke, and the Finnish Environmental Institute, which is the coordinator of the consortium. The fields of activity varies from physical and geological oceanography to marine biology, chemistry and fishery sciences to the blue growth. And the range of key competencies is also wide, from field and experimental research, modeling and databases to marine technology. And what is important to note is that the three universities of Finnmari are responsible for most of the university-level marine sciences education in Finland. Here is a summary list of our key infrastructures. So we have research vessels, alkaline ferry walks, autonomous buoys and gliders, different kinds of experimental facilities and laboratories, automated real-time observations, field stations, traditional research equipment, and modern research instrumentation. And I'll show you in the next 3 slides a closer look at some of the facilities. The field stations of Finnmari are located on the environmental gradient of the Finnish coastline. Husö Biological Station of Åbo Academy in the Åland Islands and the Archipelago Research Institute of the University of Turku on the island of Seili present the inner archipelago sea area, while the Tvärminne Zoological Station of the University of Helsinki represent the outer archipelago of the Gulf of Finland, and finally the Uutö field station of the Finnish Meteorological Institute is facing the big Baltic proper. Our research vessel fleet covers ships which are suitable for different kinds of uses and conditions. And all of them are equipped with sampling gear and laboratory spaces depending on the needs. And they also can be equipped with additional instruments according to the needs of the customer. While Aranda is optional for cruises in the open sea, here on the left, the rest, Geomari, Aurelia, and Augusta, are much more agile and better suited for works in more shallow coastal areas. And Geomari of the GTK is equipped for sea floor research, while the others are more for the open pelagic environment. Examples of our autonomous observation instruments are Argo floats, ice buoys, profiling buoys and gliders, which largely belong to the Finnish Meteorological Institute and measure mainly physical parameters of the sea. Finnmari also has a network of profiling buoys, one on each field station, and the purpose of those are to measure and observe different variables or same variables in different locations throughout the growth period from spring to autumn. In addition to these examples, we are currently building a catalog of the facilities of Finnmari. So what is inside the laboratories, what kind of instruments we have, what field equipment, and so on. And you can find them in our web pages, Finnmari Infrastructure/Gear Gallery. Now some words about our international collaboration. Finnmari partners collaborate with several European research projects and infrastructures. They also deliver observation data to the European databases such as EMODNet, CMEMS, and CDataNet, as well as ICES and HELCOM. At this point, the interesting thing from the Gulf of Finland point of view is the collaboration in the Jericho RI. Jericho is a joint European research infrastructure for coastal observatories. It is an integrated pan-European multidisciplinary and multi-platform research infrastructure for holistic observations and research of coastal marine systems. So it is a continuum of collaborative projects already since 2011. And currently the consortium has more than 39 partners in more than 17 countries. So one of the current activities of Jericho is the coastal pilot super sites. Gulf of Finland is one of the 4 pilot super sites in this map here. And the rest are the North Sea and the English Channel super site, the Northwestern Mediterranean, and the Cretan Sea in the Eastern Mediterranean. And the work in the Jericho Gulf of Finland pilot super site is carried out in collaboration with the Tallinn University of Technology and the Leibniz Institute for Baltic Sea Research, Finnish Meteorological Institute, and Syke. The objectives of the pilot super sites are, well, multi-platform observational approach, a spatial, temporal, and extensive multidisciplinary coverage. So making collaborative work and do that together with other institutions and other nations. And for example, the Gulf of Finland network, it includes different approaches from ferry box measurements, the observations at the Uto station, different types of autonomous instruments, monitoring cruises, as well as experimental work. And the other important objective is then to test how joint transnational and trans-institutional collaboration in marine observation can be done, and what are the results, and what more it brings than doing that all only on your own. And this is about the future, the next steps in Finnmari. Now, on the national FIRI roadmap, Finnmari is now at the phase of advances to implementation for the 4 years starting from 2020. And after 2024, it should be fully mature research infrastructure, which can offer open access, data, and services to the research community and other stakeholders. And therefore, our focus areas during the next 2-3 years are data and open access. So we work hard to develop open access protocols for the research facilities and develop the data management to meet the FAIR principles, and FAIR meaning findability, accessibility, interoperability, and reusability, to have everything going well. And that was my last slide. I stop here and thank you for your attention, and more information you can find from the net. So thank you.
A promising initiative. Some questions? We have time for 1 or 2. No? Then thanks again. And
thank you.
Yes, thank you very much. And our next speaker, Victor Bolbot from Aalto University. Can you hear us?
Yes, I can hear you. Can you see me?
Yes, we listen you. Hopefully we'll
Good,
see
good.
you soon. Yes, please. Great. So the floor is yours, please.
Okay. So good afternoon, ladies and gentlemen. My name is Victor, and today I will. I think oops, I'm sharing you with the wrong presentation. Just give me a second. Let me share it again. That's what can happen when you have too many windows open. You start essentially getting confused in your own material. Okay, that's the right presentation. Can you see it now? Oh, okay. Yes. Okay. So here is the right presentation. My name is Victor, and today I will make a presentation related to autonomous technologies. And the aim of this presentation is to explore the potential of autonomous technologies for achieving sustainable Gulf of Finland. So first I will present some information about Aalto University, and then I will go quite quickly to save some time, and we'll present some projects we have worked at Aalto with respect to autonomous shipping. And then I will present the result of SWOT analysis, which is connected to the use of different autonomous technologies. So Aalto University has a small group which is focusing on research related to marine engineering and technologies. We have different study paths, and our group is quite small comparing to the other groups on international level, but we are quite active. And we are currently the only group from Finland, which is included into Shanghai ranking, and we are considered to belong to the best 50 universities on this topic. Now, coming to more in connection to the topic of the presentation, as you might know, the autonomous shipping is becoming a more tangible reality, and during the last week, we heard that finally Yara Birkeland will be fully operational, and this will be a first example of a fully unmanned vessel which will be used for commercial purposes. We are also seeing a number of other projects which focus on ro-ro ferries, container ships, inland waterway vessels, and we are somehow anticipating a breakthrough in these areas quite soon. And a number of countries are working in connection to autonomous shipping, and Finland is just one of them. Now, the development of autonomous technology is expected to have some benefits, as it will contribute to reduced operational costs, because we will be having no longer crew to pay. We also expect to have reduced CO2 emissions, improved safety, increased job accessibility, because we will move some number of jobs from shore to the sea, to the shore, and it will also open potential for new markets. Now, coming to the project that we have been working at Aalto University. So one of this project is Alivesi. In Alivesi, we have investigated the use of autonomous technologies for an unmanned city ferry, and we have investigated different aspects related to safety and environmentally friendliness of this potential alternative solutions. In Automare, which is an on-running project, we are focusing on research which is conducted currently on a global level, but we mostly consider what sort of amendments we need in order to train next generation maritime experts. And here in this project are practically all the Finnish universities which are involved in the maritime education one or another way are participating. And the aim is to identify what sort of autonomous technologies we have or might have, and how to educate the next generation seafarers and marine designers. In ECA Maris, we are developing some specific, more technical solutions. This is simply being implemented in cooperation with a number of other partners. and we are investigating different concepts like relocated bridge, conditionally periodically less manned bridge, and conditionally and periodically unmanned bridge. In C4 we are investigating how we can increase digitalization and how we can use it to develop new services. And specifically, we focus on remote pilotage, which is one of the services. The financing in this project is offered by the Business of Finland, and we investigate different concepts related to intelligent failure and remote pilotage. Now, how does this connect to all the discussions that we have heard today in various presentations? For that purpose, we have used a SWOT technique, which is quite good technique for preliminary decision making and which is quite efficient for initial planning. And using SWOT techniques, we have considered and brainstormed what sort of autonomous technologies can be used in order to solve the problem related to environmental pollution and greenhouse emissions and so on. The results that we provide in the next slide are of a preliminary nature, and it doesn't mean that these are concluding findings. They're based mainly on brainstorming that has been implemented here at Aalto. So the first idea is idea quite similar to Yara Birkeland, which is a ship which is operating now outside the coast of Norway. So essentially, we investigated the potential of using unmanned cargo ship between Tallinn and Helsinki, which is one of the routes in the Gulf of Finland. And some of the strength of that solution would be the reduced operational cost, obviously, and improved safety due to the use of automation, resilience in the supply chain, since we will not rely on the crew for operations, but only on the systems. And this can be a completely novel design, and by redesigning the vessel, we can reduce the resistances and we can have much less CO2 emissions through better energy efficiency. And this could be potentially coupled with autonomous ports and trucks in the future if they're developed, and this will increase the operability of such supply system. And obviously, this can be used also for other shipping routes in the Gulf of Finland. But what we could see is that some of the propulsion systems that are in use and which are eco-friendly, like batteries, might not be enough. So the problem is the battery capacity, and that's why we can have operation using batteries only in near coast areas. We don't have any ocean-going vessel which is using batteries. And there might be some need for infrastructure update. But the main concern that we have is that it might be not financially stable. Yes, it's technically feasible, or with some, after overcoming some barriers, we might reach a solution which is operating, but it might be not very strong in terms of financial performance. Now, another potential for use of autonomous technology is the use of small open ferries, which are automated. This is similar to different other projects which have existed. One of them is Alivesi, where we have worked, and another one is Emilian Bear, which is currently being implemented in Norway. And by redesigning the vessel again, we can reduce the emissions, and we can also improve safety. But of course, the threats that we are facing here are mostly related to safety, because we need to demonstrate a very strong safety case. Yeah, we can also have some issues with the battery capacity, but here it's more feasible to use batteries than in the previous case. So that's definitely an option that can be considered to reduce the CO2 emissions in the ports. And this sort of solution can be applied in the Helsinki area, but it also can apply it in St. Petersburg and yeah, maybe in other cities which have some sort of urban ferries. The third idea is more practical and directly related to what has been presented, and it could be potential. It would worth investigating the use of a small autonomous vessel, which would be collecting the floating garbage on surface in the area of St. Petersburg, Helsinki, and Tallinn. This idea has been already tested in some other countries, and it has very small safety implication. And it's also quite simple and straightforward for use. But of course, the main challenge is that the developers in the local area cannot use the solution because there might be some IP issues. So the idea is already protected by some patents. The fourth idea is also related to what has been previously presented. We already have seen in the previous presentation that some autonomous technologies are used for monitoring purposes, but these are some alternative solutions which could be also used to monitor the environmental KPIs in the area of Gulf of Finland. So we could have used different drones, and drones have been suggested for use to monitor compliance with SOx emissions. But also we could use drones for sampling the water and to see if we have eutrophism or other problems. The advantage of that solution is that we can deploy this system indefinitely in some period of years. So for instance, in summer, we can have such vessel constantly in operation because there's sunlight, and we can charge the batteries using the solar panels. These solutions are also not threatening the safety of navigation, and these solutions also can increase the frequency of sampling in the different areas. So just coming to the last slide, the autonomous ships and technology are becoming more and more tangible reality. And we as Aalto have some experience in connection to autonomous ship development and projects. In connection to the Gulf of Finland sustainability, the autonomous technologies could be used to promote and support the development of novel and greener supply chains. We could also use autonomous technologies to reduce the operational costs, and we could also use the autonomous technology in order to clean and also to mitigate some environmental hazards like microplastic floating on the sea. And we could also use the autonomous technology for better monitoring activities. This is all from my side. I would like to thank you all for your attention, and I'm very glad. I'm open to hear any questions. Thank you very much.
Thank you very much, Victor. Really very interesting talk. It looks fantastic, but nowadays technologies are more and more real, even fantastic technologies. So I just can imagine how the huge scientific vessel is exploring constantly some areas like Russian Arctic, for example, yes, and sending us more and more data every day. It's a dream. But, questions? Then maybe I have one, do you have any information about the legislation? Is it possible in national or international level right now, or some perspectives of such laws?
Well, in connection to the international operation of unmanned vessels, I think that's something quite challenging for the moment being. So the projection is to develop some regulation at IMO level by 2030 or so. So it's gonna delay, unfortunately. But on national level, there is much more freedom. So, and I think that national authorities are quite open to the use of autonomous technologies, and they can grant permission for operation of such vessels, provided that there is a demonstration of sufficient safety. So essentially, if you do some risk assessment, if you follow some procedure and you demonstrate that you have taken safety into account quite seriously, I think that's possible.
Thank you. So let's meet in 2030 and check. Thank you again. Very interesting talk. Thank you.
Thank you.
And the next talk, also online, Taavi Liblik from Tallinn University of Technology about stratification in winter and its consequences. Taavi, can you hear us?
Yes.
Okay, great.
I forgot. Okay. So, hello everyone. I talk about stratification in winter and its consequences in the Gulf of Finland. And the background of this story is or comes from the fact that the Büchnock line or vertical density gradient is very, very important in the marine systems, and it determines the physical and biogeochemical fluxes, and it is also very important for the onset of life, I would say, in ocean or sea, for the primary production as well. So if the mixed layer is or the Büchnock line is shallow or at least comparable to the light-rich zone in ocean, then primary production is very effective. And in the Baltic Sea, in most of the Baltic Sea, we have a deep mixed layer during winter, which is as deep as 50 or 60 meters, much deeper than euphotic zone. But in spring and summer, it is at least in the same order, so the primary production is effective. On the other hand, there are some papers which has reported about wintertime stratification under ice. And these areas are usually near some freshwater source, near some river mouth. Here is one example in the Swedish fjord. And when we see the Gulf of Finland, we have actually several preconditions for such phenomena. We have a very large freshwater input, which is concentrated to the east. We have a elongated shape. And we have also very low temperatures. So sea surface temperature passes the maximum density temperature every year. So the main idea here is that we should also have wintertime stratification in the Gulf of Finland, and that should that should cause mixed layer depth comparable to the euphotic zone, and we should see this also in primary production. And we have done several ship surveys already a while ago. These ship surveys were actually dedicated to study deep layer of the Gulf of Finland, but we saw some interesting results, and then we later did also model runs and checked the ferry box data and also checked the historical CTD data. So our main study area is, I hope you see in this area, really in the Gulf of Finland, in the Western Gulf of Finland. These are the sections. And now I show already the sections of temperature, salinity, density, and chlorophyll A. On the left, there is a distance 0. This means mouth, or more or less mouth of the Gulf of Finland, and 120 kilometers is somewhere in the, let's say, in the Sillamäe or this area. And you can see that first snapshot what we had in the end of December, we had very mixed conditions. This is what is expected from the literature. On the other hand, the second visit, we already see some freshwater patches in the eastern part of the section, and very, very slightly, but still one can see also some higher chlorophyll A values, which is a proxy of phytoplankton biomass. Then next survey in the beginning of February, there is a very clear signal of low salinity water here, which is reflected also in density distribution, and which is reflected also in the chlorophyll A. And you can see the temperature in this case is somewhere near 0 degrees. Then we had some westerly wind impulse. So these colors here in this column, they show, or they correspond to somehow to wind. So if it is blue, there is a more easterly wind. If it is west, if it is from west, it is red. So there was some westerly wind, and this pushed down a bit this Büknok line, and also the chlorophyll A is not so high. But then in the mid-March cruise, we had very high values of chlorophyll A, and this is very well related to the Büknok line. So the main point here is that it seems that at least from this measurements, this onset of stratification happens already in February or so, so much earlier than it was believed before, and also it is causing onset of phytoplankton, not bloom, but let's say growth. And we had similar observations also in 2014 and 13 and 14 winter, but I don't show them, but they basically show the similar pattern. Okay, to see what is the, let's say, temporal pattern of this phenomena, I show here Tallinn-Helsinki ferry box data from 2 winters. On the left, there is a salinity, and on the right, there is a temperature, and this distance is distance 0 is more or less Tallinn Bay, 70 is near Helsinki. And these are time series from January to March. And you can see that in the beginning of the year, in both years, there is quite high salinity in the surface layer. So the ferry box is measuring salinity and temperature in the surface layer about 4 meters depth. But then already in January, actually, but very clearly in February, some fresh water is arriving to this Tallinn-Helsinki area, I would say Helsinki area, yes. And after some time, let's say after 1 month, this fresh water is spreading to the south as well. And this pattern in 2 years was very, very similar. And to see how this looks in space, I present here modeling results. This is from winter 2011-2012. First of all, there was a westerly wind prevailing, which is causing a kind of blockage of fresher water advection. Of course, it cannot block it entirely, but it prevents this riverine water advection. So the parameter here is the mixed layer depth. So these are in meters. So it is quite deep. Then when easterly winds prevailed, this allowed to spread all this fresh water along the northern coast of the Gulf to the west. So in this area already the mixed layer was very, very shallow and stratification was already on set. And then 2 days later, there was a short westerly wind impulse, and this current, Ekman current caused by westerly wind, caused this widening of this fresher water area, and this area covered by shallow and productive upper mixed layer. So this is how it works, we believe, or at least this is how our measurements and modeling shows. And there is also some statistics here based on modeling. There is on the left panel, there is upper mixed layer depth, the mean depth in these months. This is November here, December, and so on. And on the right, there is a occurrence of upper mixed layer depth below 20 meters. And you can see that in November, December, this upper mixed layer is very deep, and the shallow mixed layer is very unlikely. In January, there is also already some shallower mixed layer can be seen. Then in February, there is already quite clear occurrence of mixed layer below 20 meters depth in the northern coast, as we saw this from this 1 year example. And in March, there is already more or less the whole Gulf quite often filled by the mixed layer or the shallow mixed layer. And to see what is the or how this looks from the historical measurements, here I show the longitudes on the horizontal axis, and on the vertical axis there is occurrence of density difference, which also kind of indicates if there is stratification in winter or not. And you can see that this 23 degree of degree east is the western border of phenomena, and we believe that it is just the coastal morphology, so that the Gulf of Finland extension gets wider, and somehow this fresher water spreads, so that you cannot see very clear stratification anymore. Okay, and here I show the time series, long-term time series of upper mixed layer depth. This pink line is coming from Eastern Gotland Basin, just for comparison, and black line is from the Gulf of Finland. And you can see a couple of interesting things here. First of all, the maximum upper mixed layer depth happens already in December almost every year, and it happens before SST decreases below maximum density temperature. So this means that it is solely it is mainly from the wind mixing is deepening. And on the other hand, the onset of this stratification happens temperatures below this maximum density temperature. So this means that the onset of stratification is not related to the warming, but to the fresher water advection. And I have also here now index. It is quite clear that if the winter now index is positive, then the mixed layer is deeper because of more westerly winds and more mixing. And if there is a negative now, it is rather shallow mixed layer in winter. And over 2 years when we had this ship measurements, these seem to have a positive now. So this means that actually on average this winter stratification is even more common. So these are my conclusions. We report here that stratification at the depth comparable to a photic zone forms already in late January or early February. along the northern coast and 1 month later in the whole Gulf. The mechanism is related to the buoyancy flux coming from the fresher water advection. We can see the elevated chlorophyll A and actually also phytoplankton biomass. I didn't show today, but we also measure phytoplankton biomass there, which is also elevated. And it seems that this feature or this phenomenon is quite common and in the Gulf of Finland. And it also seems that it is related somehow to the North Atlantic Oscillation. And the last thing here is that this study is actually published. So that's all from me. Thank you.
Thank you, Tavi. Some questions? Still have time. Okay, so thanks a lot again. And now we have our last speaker for today, Ekaterina Ivanova from Institute of Limnology, Russian Academy of Science. Please.
Presentation. Excuse me, could you change presentation? The name is Kondratiev. The last one. No, the last one. Mm-hmm. No, it's not mine also. Sorry. Yes, the first one. No, the first one, yeah. Hmm. Yes, that's it. Okay, excuse me. So good day, dear colleagues. My name is Ekaterina Ivanova. I'm from the Institute of Limnology, Russian Academy of Sciences. And I would like to present our research results of climate impact on runoff and nutrient load for the Gulf of Finland tributaries. This research has been done in the framework of the project Sevira. The project Sevira, Water Meets People, Learn, Act and Influence. It is a project of a program Southeast Finland, Russia, cross-border cooperation. And its name, Sevira, it contains first letters of 3 rivers, Sestra River in Russia, Virajoki River in Finland, and Rakolanjoki, it is transboundary river. And the aim of this project was to take some steps forward to improve environmental situation in this area by combining some scientific and social activities. In this project, we did Field research, monitoring works to analyze quality of water in the catchments of these rivers. And also we did modeling research to analyze possible changes. And our partners did some social actions, including surveys of local habitats, educational work with school pupils, cooperation with local activities, and others. So in the result of this project, we will develop recommendations and roadmap for stakeholders and decision makers. But in this presentation, I would like just to show our results of a modeling part of this project. And as I said, we did estimation of possible changes in runoff and nutrient load by the Gulf of Finland tributaries in case of a climate change. So to do it, we used two models which were developed in our institute. It is a hydrological model of runoff and model of nutrient load. So hydrological model, it includes some hydrological parameters like precipitation, temperature, evaporation, snow cover and melting, soil moisture, and in the result we have total runoff, fast and flow, and can analyze water level in reservoir. And nutrient load model, it includes natural and diffuse anthropogenic load from agriculture and not agriculture areas, and also point load. And at the end, we have total nutrient removal in catchment and total nutrient load on water body. To verify our model data, we use calibration. So here you can see calibration graphs for 3 rivers. Red line is monitoring data, blue line is calibrated data, and black line is verification. So Nash-Sutcliffe coefficient shows that our model data are quite satisfied, and we can use it for further modeling. To estimate possible changes, we used scenarios of IPCL French model of a climate change. On the left graph, you can see 4 scenarios, but we analyzed just 2 of them. Green scenario RCP 2.6 when we have low emissions, and red scenario RCP 8.5 when we have the highest emissions. So according to these scenarios, we calculated changes in different meteorological parameters. For example, here you can see changes in precipitation for both scenarios. It increases a little bit in both cases. Then temperature, it doesn't change for the green scenario, and it increases significantly for the red scenario. So we also calculated evaporation for both 3 rivers and runoff. So evaporation doesn't change for the green scenario and rises significantly for the red scenario. We have the same, more or less the same situation for 3 rivers, and as the result, runoff, it even decrease in case of green scenario and increase a little bit in the case of the red scenario. Here you can see our main results for the 3 catchments. So we can say that nutrient load in case of green scenario RCP 2.6, nutrient load will decrease a little bit for all 3 catchments. And in case of red scenario RCP 8.5, it will significantly increase. And for the catchments, the highest nutrient load
we fixed for Kalanjoki catchment. Maybe it is connected with large sewage treatment plants in Lapinranta. And the minimum nutrient load was fixed on the Virajoki catchments due to high forest coverage. But these two scenarios are really extreme cases, and it is very likely that the real situation will be somewhere in the middle. And this is most likely that by the end of the 21st century, we hardly expected significant changes in the hydrological regime and nutrient load in the studied area caused by climatic changes. So there is the main conclusion. And we would like to say many thanks to our colleagues, Sirka Tatari and Jari Kosku from Suki Institute. Thank you very much.
Thank you, Katerina. Questions? Then maybe I have one. As far as I understand, you study Sestra River.
Yeah.
So it's how do you think Sestra now is going to the like lake reservoir, Sestrarecký razliv. So does the runoff of this river impact just on this water body or also to Gulf of Finland?
I had a map there, so yeah, it's really not far from the Gulf of Finland, so its catchment is quite close to the Gulf of Finland, so probably it should influence somehow to the Gulf as well. Thank you. Thank you.
Once again. And let's thank all the speakers of afternoon session. And now our session is over, and Tarmo Sommeri has a very important announcement as far as.
Yes. First of all, apologies for the last missing presentation. The first author had some health conditions and related family issues, so she was not able to complete the presentation. But I still think that the audience deserves some 90 seconds about what the basic idea is. When you are trying to forecast future extreme water levels and how frequently they occur, then you normally rely on some generalized extreme value distributions, some theoretical distributions, and you think implicitly that situation is statistically stationary. So you think that the situation doesn't change in time. This is, of course, not correct spatially. So the parameters of such distributions, they change massively along the southern coast of the Gulf of Finland. But what Nadia has found is that those parameters also change radically in time, which means that your forecast for future extreme water levels and probability of their occurrence and the time scale at which they occur will strongly depend on which data set, which time slot for data you take into account. It's a very bad message for those who have to project future extreme water levels. And now comes the real announcement. There is no poster sessions. The posters are on 2 floors, this floor and upper floor. Why this is important? In 2 hours and 10 minutes, there will be a reception by His Excellency, the Finnish ambassador. You need for entering Finnish embassy, which is in neighboring house, several things. You need an invitation, which you have in your conference bag. You need a vaccination certificate. You need a mask. And you probably need an identification card or passport. And moreover, related to the poster session, at the entrance there will be questions about random posters with the goal to make sure that you are actually from this conference and not just a stranger trying to... Please take it very seriously. Look through all posters and try to make sure how the results depicted on the posters could affect diplomatic relations between our three countries in the even extreme future. And a very small announcement, a butterfly tie has been found that it's available at the reception. So enjoy the posters and keep in the memory maximum amount of information what you can extract from there.